We want to solve AIME II 2023, and before exam of AMC for this year 2022, around 2 months ago, I released a video preparation. I told some ideas, general ideas useful in AMC, AIME, and other levels. We will use many of those ideas here. Okay, let's start. Problem number 1. It says the numbers of apples growing on each of 6 apple trees form an arithmetic sequence where the greatest number of apples growing on any of the 6 trees is double the least number of apples growing on any of the 6 trees. The total number of apples growing on all 6 trees is 990. Find the greatest number of apples growing on any of the 6 trees. Okay, suppose, for example, the numbers are like this: A1, A2, A3, A4, A5, A6, so you can say also less than or equal. Form an arithmetic sequence, the number of apples in first tree, second tree, and this. Then it says form an arithmetic sequence. Okay, so we know the formula of an arithmetic sequence is an equal to a plus, or let's say a1 plus n minus 1d. It's when you have an arithmetic sequence, use this formula, basic formula, and you can solve the problem. Okay, let's use this. The first thing we have, it says greatest number of apples growing on any of 6 trees is double the least number of apples growing on any of the 6 trees. It means what? It means a6 equal to 2a1. The next one, the total number of apples growing on all 6 trees equal to 990. So a1 plus a2 plus a3 plus a4 plus a5 plus a6 equal to 990. Now I want to use this formula, the first one. a6 equal to a1 plus 6 minus 1 times d equal to 2a1. So we conclude a1 plus 5d equal to 2a1. If we take a1 to right hand side or subtract a1 from both sides, we conclude 5d equal to a1. It is our first equation. Now let's analyze second equation. Okay, so a1, a2 is a1 plus 2 minus 1, 1d. a3 is a1 plus 2d. a4 is a1 plus 3d. a5 is a1 plus 4d. And we can write the rest here. a1 plus 5d for a6 equal to 990. Now, here, let's consider this first equation we need. Second one, we have a1, 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 3, 4, 5, 6. So it's 6a1 plus. If we factor from d, we have 1, 2, 3, 4, 5. So it will be d1 plus 2 plus 3 plus 4 plus 5 equal to 990. You can use formula for 1 to 5, or you can calculate manually. Say 1, for example, plus 5, 6, 4 to 6, 12, 15. Or you can use formula, which 1 to n equal to n times n plus 1 over 2. Now we can say 6a1 plus 15d equal to 990. Okay. Now we use first identity. Instead of a1, we replace it with 5d. So it will be 6 times 5d instead of a1 plus 15d equal to 990. Now the next one, 30d plus 15d equal to 990. In next step, 45d equal to 990. Okay, if we divide by 45 both sides, it will be 2, 90, 22. So the first variable we need is 22. If we use again first one, we want to find a1 equal to 5d equal to 5 times 22 equal to 110. Okay, we found also A1 is what? But the problem wants what? The problem says find the greatest number of apples growing on any of the 6 trees, means A6. If we use this formula, basic formula, A6 equal to A1 plus 5D. If we replace A1 with 110 and D with 22, 110 plus 5 times 22 equal to 110 plus 110, which equal to 220. So the answer of this problem is 220. As I said, for example, when you see arithmetic sequence, use this most of the time useful. If you want to know important basic formulas that you should know for each problem, for example, when you see arithmetic sequence, use this. When you see GCD or greatest common divisor, use these forms. We have some general and famous forms. If you want to know them, feel free to send message. My WhatsApp number in the description and comments. AIME II 2023, problem number 2. Recall, palindrome is a number that reads the same forward and backward. Find the greatest integer less than 1000 that is a palindrome both when written in base 10 and when written in base 8, such as 292, which is 444 in base 8. Okay, let's consider first the largest number that we can use, 999. If you want to write it in base 8, 999 when we divide it by 8, it will be 1, 19, 2, 39, 4, it will be 7, the remainder. If you divide it by 8, it will be 15, the remainder is 4. If you divide it by 8, it will be 1, it will be 7. And you use this, and this one. So 999 in base 10 equal to 1747 in base 8. So at first, the number we want to select, we consider the number of digits in base 8. Number of digits in base 8. Okay. If it is case 1, for example, suppose this variable, we call it n, case 1. If n is 4, so the number in base, for example, 10, you call it ABA. In base 8, because we have 4 digits and the largest possible case is this, so the first digit only can be 1, because if it is 2, then it will be greater than 999. It should be 1, also it should be 1. And it is 7, so we can consider, for example, it is C, it is C. It is in base 8. So you should know how to change from base 8 to 10. You should multiply it by 1, multiply it by 8, multiply it by 8 squared, multiply this one by 8 cubed. So in base 10 also, we know you should multiply it by 1, multiply it by 10, multiply it by 10 squared. So 10 squared is 100, 100a plus 10b plus a equal to 8 cubed, which is 512, 8 squared, which is 64c, plus 8c plus 1. And then in next step, 100a plus a 101a plus 10b equal to 512 plus 1 513 plus 72c. Okay, so we consider n equal to 4 first because we want the problem says find the greatest one, greatest integer that is possible. So here, because the number is ABA, we should maximize A as much as we can. Also, it is equivalent to maximize C. So, but A is more important than B. Now here, on left side, we will see it is even. This part is even, this part is odd. So left side is odd, right side is odd. So we conclude that this part also should be odd. So A is odd because it is even plus what is odd? Odd. So A is odd. Now we start from greatest one, case 1, 1. If A equal to 9. If you check, for example, 9, then you should check 7, then 5. If you check one of them, then you understand how to check the others quickly. A equal to 9 will be 909 plus 10b equal to 513 plus 72c. Now, if we subtract 513 from both sides, it will be 6. 10 minus 1 is 9. And 8 minus 5 is 3. Plus 10b equal to 72c. Now in next step here, we divide both sides by 2. Then if we divide both sides by 2, it will be 198 plus 5b equal to 36c. Now 198 is 2 times 99. It's even. It is even, so we conclude that b also should be even. So b is 2b prime. So we conclude 198 plus 10b prime equal to 36c. Now if we divide by 299 plus 5b prime equal to 18c. Now here we will see it is multiple of 3. 3 divides this, 3 divides this, so we conclude 3 divides b prime. So b prime equal to 3b double prime. So 99 plus 15 b double prime equal to 18c. Also, you could, at first you say b equal to 6 times something. You could do that also. If we divide by 3, 33 plus 5b double prime equal to 6c. Also, again, we can say b double prime is 3 times, for example, b1, because it is 3 divides this, 3 divides this, so one term is left, so 3 divides also b double prime. So 33 plus 15 b1 equal to 6c. So 11 plus 5b1 equal to 2c. So let's just review the things we reached. B was 2b prime. B prime was 3b double prime, which is 6b double prime. B double prime was 3b1, so it's 3b1, which is 18b1. So because b is a digit, so the only possible case is b1 0 and b equal to 0. So if b equal to 0, a equal to 9, and here b1 is 0, so let's see c is what? So 11 equal to 2c. And we conclude that c cannot have any integer, cannot be equal to any integer, so contradiction. So case 1, a equal to 9 was rejected. You could also reject it quickly considering parity first. For example, consider 19836 their GCD, or 39672 and divide it by the GCD, and then consider the parity. But we want to just analyze to see how we should work on these types of problems. It was case 1. Now let's consider case 1-2. We said A is odd, so the next case we should check A7 because we want to find largest. After 9 we check A7. Now if we replace it, A with 7 in this equation, 707 plus 10b, 707 plus 10b equal to 513 plus 72c. 513 plus 72c. Okay, let's subtract. 707 minus this is 194 plus 10b equal to 72c. Now let's divide both sides by 2. So it will be 97 plus 5b equal to 36c. Okay, now if we consider mod 5, 97 is 2, b is 0, is congruent to 36 is 1 mod 5, c. Modulus so much useful. So, because c is what? C is the digit here, mod 8, it can be from 0 to 7. So it can be only 2 or 7. So we should check only these two cases. For previous cases also we should work on c. So if c is 2, 97 plus 5b equal to 72. It's bad. Because this part, b is at least 0, is at least 97, but right side is 72. Now let's check C7. So it will be 97 plus 5b equal to 36 times 7. 7 times 6, 42. We have 4. 7 times 3, 21 plus 4, 25. Now we conclude 5b equal to 252 minus 97. 12 minus 7, 5, 4, 14 minus 9, 5, and 1, 155. So if you divide both sides by 5, b equal to 3, 1. Okay, b is so much large because b is digit. It should be between 0 to 9. It's in base 10. It was case 1, 1 we've checked. A9 case 1, 2, A7. Now let's check case 1, 3. If a equal to 5, so 100a, it is 505 plus 10b equal to 513 plus 72c. If we subtract by 505, 10b equal to 5 plus 3, 8 plus 72c. Now, we know that because let's open a new page. Okay, here we know that it is multiple of 8, it is multiple of 8, so this part multiple of 8, so b should be multiple of 4. So we can say b equal to 4b prime, so 40b prime equal to 8 plus 72c. Now we divide both sides by 8, so it will be 5b prime equal to 1 plus 9c. Now, because b is 4b prime, b prime can only be 0, 1, 2, because if b prime, for example, 3, then it will be 12. So let's check these 3 cases. So b prime 0, 1, 2. If b prime is 0, we want to check c is what? Then 0 equal to 1 plus 9c contradiction. So here it's undefined contradiction. If b prime is 1, then 5 equal to 1 plus 9c. So 9c if you subtract by 1 is 4. It's not possible, again contradiction. B prime equal to 2, 10 equal to 1 plus 9c, so c equal to 1. So we conclude this case. Okay, so from this case, c equal to 1, a we said is 7, from first, a is 5, here we said, and b is what is 4, b prime 4 times 2 is 8. So our number was what? ABA. So ABA, the number is, through this, that shows it is a number in base 10. Also here we could draw this, means it is not product, it is a number. Then it will be 585. So the greatest number that we have is 585. This problem had a lot of different solutions. You can consider mods, for example, mod 5, mod 2, mod 8. And some solutions are faster, some of them needs more calculation. But the whole idea of these problems is this. If you want to learn other ideas, as I said before, feel free to send message to my WhatsApp number in the description comments. AIME II 2023, problem number 3. Let triangle ABC be an isosceles triangle with angle A equal to 90 degrees. There exists a point P inside ABC such that PAB. Okay, so let's draw. Okay, it is our triangle. It says PAB. This angle, for example, is alpha. PBC is alpha. PCA is alpha. And AP is 10. Now find the area of ABC. So we know if this length is A because it is isosceles triangle, it is A. Because it is right angle triangle, A is 90, you can use Pythagorean theorem. So BC squared equal to a squared plus a squared equal to 2a squared by Pythagorean theorem, and bc equal to a root 2. So we write it here, a root 2. Now let's work on angles. It is isosceles right angle triangle. It is 45. It is alpha, so it is 45 minus alpha. This angle is also 45 minus alpha because the whole part is 45. It is 90. It is alpha, so it is 90 minus alpha. It is 90 minus alpha. It is alpha, so this angle is 90. This angle is what? Alpha plus 45 minus alpha is 45, so it should be 135. Similarly, it is also 135. Now we should use sine law. As I said, some important basic things you should pay attention in AMC AIME, Pythagorean theorem, sine law, cosine law in preparation before AMC I told. But except those, sometimes we have internal angle bisector, external angle bisector, x radius, x center. They have formula. For example, RA, its x radius of A is area over S minus A. We have a lot of formulas, 40, 50 formulas. If you want to learn them, they are useful from AMC up to IMO. If you want to learn them, as I said before, feel free to send message to my WhatsApp number in the description and comments. Okay. The problem, we want to find A. If you find A, we can find the area. A is here, it is 10. So if you know sine alpha equal to what? Equal to AP in triangle APC. Opposite to hypotenuse. AP is 10 over A. So A equal to 10 over sine alpha. So if we can find sine alpha, then the problem will be solved. So here 35 PC. Now we found an equation in terms that it contains A and sine alpha. If we use sine law in triangle BPC, then we can say PC over sine alpha equal to A root 2 over sine 135. It will be A root 2 over 135 is root 2 over 2, or you can write it as 1 over root 2. Then if you multiply both numerator and denominator by root 2, it will be 2A. Okay, so we conclude PC, if we cross multiply, equal to 2A sine alpha. From here, you can say sine alpha equal to 10 over A. If we call it a star, then by applying a star, PC equal to 2A, instead of sine alpha, we write 10 over A. These A's will be cancelled, so PC will be 20. Okay, so let's write PC 20 here. Now we can find A easily by Pythagorean theorem in triangle ABC. A squared equal to 10 squared plus 20 squared. So it will be 100 plus 400. So it will be 500. So A equal to, if we take square root 10 root 5. Now the area of triangle ABC equal to A times A over 2. It will be A squared or 10 root 5 squared over 2. 100 times 5, 500 over 2, which will be 250. Okay, so the answer of this problem is 250. If you pay attention, the only thing we've used was sine law and Pythagorean theorem. Okay, at first you should try basic things. Angle chasing also before that. Angle chasing, sine law, cosine law, Pythagorean theorem, use all these things. And also we have double Pythagorean theorem is useful in many problems of AIME, AIMC. If you want to know that also, feel free, as I said before, to send message to my WhatsApp number in the description comments. AIME II 2023 problem number 4. Let x, y, and z be real numbers satisfying the system of equations. We have xy plus 4z equal to 60, yz plus 4x equal to 60, zx plus 4y equal to 60. Let S be the set of possible values of x. Find the sum of the squares of the elements of S. For these types of problem, you should use replacement. It's one of the most useful idea. I solved also many problems with replacement in my previous videos. If you saw them, you understand. At first, we look, one way is to try to combine some of them, use some creativity. But in most of these types of problem, if you use replacement without any creativity, you can easily reach the solution. So it's so much important. Let's do it. Okay. Now we want to use replacement. How? From first equation, I find z in terms of x and y. So we know 4z equal to 60 minus xy if we subtract xy from both sides. And if we divide by 4, then z equal to 60 minus xy over 4. Now we replace in second equation. So let's consider first, second, third, and now the thing here we reached was 4. If we use 2 and 4, okay, so we replace z with 60 minus xy over 4 plus 4x equal to 60. Now we multiply by 4 both sides, so And we can say 60y minus xy squared plus 16x equal to 240. Okay. Now we want to find x in terms of y. So we say x times 16 minus y squared equal to 240. We take 60y to the right hand side minus 60y. Now, if we divide, we can say x times, you can factorize 16 minus y squared, 4 minus y times 4 plus y equal to 240 minus 60y. Here we've used famous identity that a squared minus b squared is a minus b times a plus b. Now I want to divide both sides by 4 minus y, 4 plus y. But here, we should check it is not 0. So, case 1. If 4y minus y is 0, then y equal to 4. The left side is 0, so right side 240 minus 60y is 0 also. So again, y equal to 4. Now, if y equal to 4, let's analyze this part. The first equation will be, first one will be 4x plus 4z equal to 60. And we conclude x plus z equal to, if we divide by 4, 15. Now if we replace in second one, if we replace y with 4z, again it will be the same thing. Let's replace, consider third equation, and replace y with 4. So it will be what? It will be zx plus 16 equal to 60. So zx equal to 50, 44. You can see that 11, 4 works. But if you want to prove completely, you can say this 15 minus x. If you replace 15 minus x times x equal to 44, then 15x minus x squared equal to 44. Now, if we take all things to the right hand side, x squared minus 15x plus 44. If we factorize, it will be x minus 11, x minus 4. Then we conclude x is 4 or x is 11. In this case, z is 11. In this case, z is 4. And in both cases, y is 4. So we found, and we can check. If we replace, you will see all both answers satisfy all three equations. So we found two answers now for x, 4 and 11. Let's check case 2. We want to divide both sides by 4 minus y times 4 plus y. If 4 plus y is 0. If 4 plus y is 0, then left hand side, then y equal to negative 4. And left hand side is 0, so right hand side is also 0. So 240 minus 60y is 0. So 240 equal to 60y. So y equal to 4, contradiction. So it's not possible now. In case 3, we consider it is not 0. Okay? So in case 3, we conclude y is not 4 and negative 4. So we can say x equal to 240. We factorize from 60. We factor from 60, it will be 4 minus y. And we divide by 4 minus y times 4 plus y. Then we cancel 4 minus y, it will be 60 over 4 plus y. Okay, so we found, let's see what we found so far. Z equal to 60 minus xy over 4. X equal to 60 over 4 plus y. Now, we consider third equation, zx plus 4y equal to 60. Now let's replace. First part, I say, okay, it's 60. Instead of z, we write 60 minus xy over 4 times x. We replace this x with 60 over 4 plus y plus 4y equal to 60. Now, in this case, we multiply both sides by 4 times 4 plus y. So it will be 60 minus xy times 60 plus 4 times 4 is 16, y 4 plus y equal to 244 plus y. Now x is 60. Let's call this one, for example, double the star. If we use double the star, we replace x with y. So it will be 60 minus 60 over 4 plus y times y times 60 plus 16 y times 4 plus y equal to 240 times 4 plus y. Okay. Now in next step, we want to divide both sides by, for example, let's check. If we divide by 4, it will be 15, it will be 4. Divide by 4, it will be 6. Now in next step, we divide again by 4, it will be 15. It will be divide by 4 here. We can factor from 60 from both sides, or we can divide here by 4. 15, 50. Okay, so it will be 15 minus 15y over 4 plus y times 15 plus y times 4 plus y equal to 15 times 4 plus y. Now here, if we use common denominator, 4 plus y, 15 times 4 is 60, plus 15y minus 15, it will be cancelled. So if we rewrite it, and let's multiply both sides by 4 plus y. It will be 60 times 15 plus y times 4 plus y squared equal to 15 times 4 plus y squared. Now in next step, 60 times 15, 900 plus y times 16 plus y squared plus 8y equal to 15 times 16 plus 8y plus y squared. Now, in next step, we can say 900 plus 16y plus y cubed plus 8y squared. 15 times 16, 240 plus 120y plus 15y squared. Okay, let's simplify as much as we can. So here we say y cubed, we consider this. Now let's focus on y squared, y squared. It will be minus 7y squared. We've considered that. Let's consider y, 60y, 120y. It will be plus 1 minus 104y plus 900 minus 700, 660 equal to 0. Now, here, look, because previous part, the problem is symmetric with respect to x, y, z, as you can see. It seems that when x, for example, 4, 11, 4 works, all these things, here y was 4. Also, we have cases that y equal to 11, and we should find it here. So if you check 11, you will see it satisfies this, so we can factorize, and one factor is 11 minus 11. We should factorize because the degree is 3, and we want to use quadratic formula, so we should find one root. Now, when we write y minus 11, we place y squared. Then we have y cubed minus 11y squared. I want to reach negative 7y squared. I place plus 4y. Then it will be y squared will be okay. Minus 44. Then you need to reach negative 104. So you need negative 60. And at the end, plus 660 equal to 0. So first one is 0 or second one is 0. If first one 0, let's check, for example, it was case 3. Case 3, 1. Y equal to 11. And x was what here? X was 60 over 4 plus y. 60 over 4 plus y, which will be 60 over 15, which is 4. And z is what? 60 minus xy over 4. So it will be 60 minus 44 over 4. It will be 16 over 4. So one answer is this case 3, 2. Y squared plus 4y minus 60 equal to 0. So we can factorize. Product is minus 60, sum is 10. So we can say plus 15 minus 4. Or no, 10, 6 I think is plus 10 minus 6. 10 minus 6, 4 minus 60. So it is 0 or this one is 0. So the first case, y equal to negative 10, x equal to 60 over 4 plus y. Then 60 over 4 minus 10 is negative 6 minus 10. And z equal to 60 minus xy over 4. It will be 60 minus 100 over 4. So it will be negative 400 over 4, negative 10. So it is another answer. And the last part, y minus 6 equal to 0. So y equal to 6. So x equal to 60 over 4 plus y. 4 plus 6, 10. 60 over 10 equal to 6. And z equal to 60 minus xy over 4. 60 minus 36 over 4. 24 over 4, 6. So here we found 3 x's. So you can check all answers satisfied. The answer says sum of the square of the possible cases of x. So in this case, x is 6. 6 is squared. In this case, x is negative 10. In this case, x is 4 plus 4 squared. Let's consider other cases that we found. x11, x4. We had 4 here plus 11 squared. Okay, so let's write 36 plus 100 plus 16 plus 1 to 1. 1 plus 6, 7, 1 plus 2, 3, this. So it will be 136 plus 137. So it will be 273. Okay, so we've solved this problem only with replacement. It has also easier solutions with a little creativity to combine them, but I wanted to tell you with general idea and let me tell you here, I explained for you these parts. If you don't need to explain, you can quickly write all these things and reach the answer. And the answer was 273. If you want to learn other important and general ideas, as I said before, for example, in algebra, replacement, other things, as I said before, feel free to send message to my WhatsApp number in the description and comments. AIME II 2023, problem number 5. It says let S be the set of all positive rational numbers R such that when the two numbers R and 55 times R are written as fractions in lowest terms, the sum of the numerator and denominator of one fraction is the same as the sum of the numerator and denominator of the other fraction. The sum of all the elements of S can be expressed in the form P over Q, where P and Q are relatively prime positive integers. Find P plus Q. Okay, let's consider R equal to A over B. When A and B are relatively prime means GCD, greatest common divisor, or HCF, highest common factor, equal to 1. It is in lowest. Then, when we consider 55 times R is 55A over B. Now, A and B we can simplify because it is in lowest term. The only possible case is to simplify 55 and B. So we have some cases, GCD of 55 and B. So case 1, if GCD of 55 and B is 1. Let me tell you all cases. GCD of 55 and B, because 55 is 5 times 11, it can be 1, 5, 11, because it should be a divisor of 55. 55. We should consider 4 cases. In case 1, if GCD of 55 and B is 1, so we consider 55A over B is in lowest term. It says the sum of numerator and denominator should be equal for R and 55R. So for R is A plus B, for 55R is 55A plus B. So here B will be cancelled, and if we simplify 54A equal to 0, so A equal to 0. When A equal to 0, then R equal to 0. But the problem says are positive rational numbers. So without loss of generality, we can consider A and B both negative or both positive. Without loss of generality, we can consider A and B are positive. Because if you negate both of them, nothing happens. So R0 contradiction. So it's not possible in this case. Let's consider case 2. If GCD of 55 and B equal to 5. So it means that B equal to 5B prime. So 55R equal to 55A over, instead of B, we write 5B prime. From here, we cancel, we divide both numerator and denominator by 5. It will be 11A over B prime. Now we know that B is not multiple of 11 because of this. So now it is in lowest term, and B prime and A are relatively prime because B and A are relatively prime. So for R, it is A plus B. For 55R, it is 11A plus B prime. B was what? 5B prime. So A plus 5B prime equal to 11A plus B prime. Now if we simplify, 5B prime minus B prime is 4B prime, 11A minus A is 10A. If we divide by 2, 2B prime equal to 5A. Okay, now we know B prime and A are relatively prime. So we know B prime divides 5A because 2B prime is 5A. So B prime and A are relatively prime by Euclid's lemma. You can ignore A, you can say B prime divides 5, so B prime is 1 or 5. 1 is not possible because if B prime is 1, then 2 equal to 5A. So B prime is 5. If B prime is 5, so then 2 times 5 equal to 5A, so A is 2. Now in this case, R is A over B, which is 2 over B prime is 5. And B was what? B was 5B prime. So 5 times 5, 25. So it is this. So the first fraction we found, and you can check 55 times R will be 55 times 2 over 25. If you divide both numerator and denominator by 5, 11 times 2, 22 over 2 over 5. So the sum of numerator and denominator here is 25, 27, here also 27. So, and the problem was what? It says sum of all elements in S, sum of all R's that are possible. So we found one fraction, 2 over 25. Well, let's check case 3 here. If GCD of 55 and B equal to 11, then B equal to 11 B prime. This B prime is not this B prime, it's better to write B1. 55 then B R equal to 55A over, instead of B, we write 11B1. So if you divide both numerator and denominator by 11, it will be 5A over B1. Now, sum of numerator in R is A plus B, and we know B is 11B1, equal to sum of numerator and denominator in 55R, which is 5A plus B1. Now, 11B1 minus B1 is 10B1, 5A minus A is 4A. Now, if we divide both numerator and denominator by 2, let's divide, and 5B1 equal to 2A. Okay, again, we can use the same thing. We can say B1 divides 2A because B and A are relatively prime. B1 and A also relatively prime, so B1 divides 2. So B1 is 1 or 2. If we replace B1, 1, it will be 5 equal to 2A, impossible, so B1 is 2. Because B1 is 2, we can conclude A is what? 10, A is 5, and B is 11, B1, so B is 22. So in this case, R is 5 over 22. And we can check, we can say, okay, 55 times R equal to 55 times 5 over 22. If we divide by 11, it will be 5 over 2 here, 25 over 2. The sum of numerator and denominator in both cases equal to 27. So we found two cases. Now, the last case, GCD of 55 and B equal to 55. Case number 4, GCD of B and 55 equal to 55. So in this case, we conclude B equal to 55. For example, B2. Now, why I've not said B1? Because we've used B1. It's better to use new variables. Do not make a mistake for the marker if it is in solution exam, full solution exam. So here we can say that for R it is A plus B, which is 55B2. For 55 times R, if we replace 55 times R, it will be 55 times B times A over B. B is 55B2, so it is A over B2. So then we can say it is A plus B2, and then we can cancel A, so 54B2 equal to 0, so B2 equal to 0. B is 55B2, so B is 0, but contradiction because B is the denominator of R, A over B. So the two possible cases are these, and it says sum of them. Sum equal to 2 over 25 plus 5 over 22. Now if we use common denominator, it will be 25 times 22. 22 times 2 is 44. 5 times 25 is 125. So 5 plus 4, 9. 4 plus 2, 6. 169. Over 25 times 2 is 50 times 11. It will be 550. Okay. Now the problem says in lowest term, it is in lowest term because 169 is 13 squared and denominator is not multiple of 13. So is P over Q. The answer says find P plus Q, which will be 169 plus 550. 9 plus 0, 9. 6 plus 5, 11. We have 1. 1 plus 1, 2. 2 plus 1, 7. So the answer is 719. Okay, here we work on GCD. GCD has some important around 8 or 10 basic rules and properties. If you want to learn important rules of GCD and also LCM, feel free to send message to my WhatsApp number in the description and comments. Okay, problem number 6, AIME II 2023. Consider the L-shaped region formed by 3 unit squares joined at their sides. Like this, as shown below, 2 points A and B are chosen independently and uniformly at random from inside the region. Here, the probability that the midpoint of AB also lies inside this L-shaped region can be expressed as m over n, where m and n are relatively prime positive integers. Find m plus n. For example, look, if a is B here, midpoint here is bad. But for example, if you select a and b here, it's good. A and b here, good. A and b here, good. So let's consider the bad cases. Okay, and we say the answer, if we want to find 1 minus probability of bad case, 1 minus probability that midpoint of AB is outside region, inside the region. So it means what? A and B should be in what places? If A and B in these places, it's good. If A and B, if one of them be here, it's good, because midpoint always is in the region. So the only possible case is one of them here, one of them here, that AB is bad. Now let's consider, for example, let's consider coordinates. It is 0, origin, it is 1, it is 2, it is 1, it is 2. For example, we call this one x1, x2. And this x1, for example, y1, and x2, y2. And the midpoint is what? Let's consider if we connect them. The midpoint is x1 plus x2 over 2 and y1 plus y2 over 2. So we say it is 1 minus, we should, for example, suppose A is here, B is here, and vice versa. So we have two cases because AB or BA. The probability that A is here is 1/3, because we have three parts with equal areas. If A is here, it is 1/3, and for B also we have 1/3. This part is AB or BA, the two first one, A in the region, B is in the region, and then times probability of x1. So look, this part should be here. Means this point is what? This point is 1, 1. So, probability of x1 plus x2 over 2, let me write like this. X1 plus x2 over 2 is greater than 1, and y1 plus y2 also over 2 is greater than 1. We should calculate this probability, and we know here x1 is between 0 and 1 because a is here. X1, let me write, x1 is between 0 and 1. y1, because it is here, it is greater than 1, less than or equal to. b here, again, you can say x2 should be greater than 1, less than or equal to y2. Look, because we want to find area, it's not safe or important to say greater than or greater than equal, because a line, for example, like this line segment doesn't have any area. The area of a line segment is 0, so, and y2 is here for this one from 0 to 1. Okay. Now we want to calculate probability. Because x1, x2 are not related to each other, we want to focus on p of x1 and x2 greater than equal 1. So let's focus on this part. Over 2 greater than equal 1, it is equal to probability of x1 plus x2 is greater than 2. Now let's analyze. We consider, for example, this is x1, it is x2, x1 from 0 to 1, x2 from 1 to 2, and if we calculate, we will see this part. Okay, now we are here because x1 is from 0 to 1, x2 from 1 to 2, and then it says find this plus this is greater than 2. x1 plus x2 equal to 2 is equal to this line. Okay, let me show you this. And when it says greater than 2, we should calculate this area from the whole area that we have here. And obviously it is 1/2, it is a square, and we should consider this area over the square. It will be 1/2. So y1 plus y2 over 2, obviously it is 1/2, and they are not related to each other. You can say 1/2 times 1. So the answer is 1 minus 2 times 1 over 3 times 1 over 3 times 1 over 2 times 1 over 2. And we can cancel these 2 and 2. It will be 1 minus 1 over 9 times 2, 18. And we can say, okay, if we use common denominator, it will be 18 minus 1. It will be 17 over 18. And the problem says what? The problem says you can write it as m over n, find m plus n. So here, 17 and 18 are relatively prime. So the answer, which is m plus n, is 17 plus 18, which is 35. Okay, in AMC also, I told this way when you want to calculate the probability, sometimes you should use areas, sometimes you should use volumes, and explain if you want to work on important ideas of probability, expected value also useful, the rules, how you can use double counting in both probabilities, and counting in AIME 2022 also was useful. And it has 3 approaches: imagination for double counting, imaginations, graphs, and tables. 3 approaches that you can solve problems in AMC, AIME, also many problems of IMO. If you want to learn those 3 approaches, as I said before, feel free to send message to my WhatsApp number in the description. AIME II 2023 problem number 7. Each vertex of a regular dodecagon 12gon is to be colored either red or blue, and thus there are 2 to the 12 possible colorings. Find the number of these colorings with the property that no 4 vertices colored the same color are the 4 vertices of a rectangle. Okay, so look, if we color and there is a rectangle, let's draw a rectangle first and then draw the circle. Okay. Okay, we have this. Now, for example, suppose we want to analyze the bad case. For example, it is blue it is blue, it is blue, it is blue. This equal to this, because they are parallel. This equal to this. And if we draw this, we conclude because it is 90, it is diameter. Okay, it is O. Okay, and also let's consider the intersection is this. So you will see it is a diameter, and it is a diameter that the colors are same. Okay, so we should pay attention. How many diameters are there? Look, A1 and one diameter is A1 connected to, let's see, A2. We have 6 ones, A1 to A7. The next diameter is A1 to A8. If you consider, I mean A1, A2 clockwise up to A12. Opposite to A1 is A7, so it is a diameter A2, A3, A7, A9, sorry, A4, A10, A5, A6, A11, A12. Okay, we have 6 diameters. We shouldn't have, for example, blue, blue, and blue, blue again. Then we have rectangle. So let's analyze if all of them have, how many diameters are there? 6 diameters. If we have only, if we don't have any, so let's consider different cases. If we don't have any diameter with the same color, always each diameter, the first one is X, the next one is Y. So for each of them, it is R, for example, for first one, it is RB or BR. So it will be 2 to the 6, which is 64. Let's consider case 2. In case 2, we consider that all of them are xy except one. One of them, for example, equal to xx, but the other one equal to, for example, xy, and something like this. So at first, you should select the diameter that you want to have same color on both endpoints. 6 choose 1 times RR or BB, 2 cases. And then the others will be 2 to the 5 because RBBR. So it will be 6 times 2 to the 6, which is 64. And it will be 6 times 4, 24. You have 2, 6 times 6, 36 plus 2, 38. Last case, case number 3. If you have 2 cases that have same color, but if it is XX, the next one should be YY. Or let me tell you, you should have one BB and one RR. Because we can't have 2 things that have BB. Again, we have this bad thing. And the other things are X, Y. So at first you should say that 6 choose 1 for BB, then 5 choose 1 for RR, then we have 4 cases that are left, 4 diameters that are left, 2 to the 4 RB or BR. It will be 30 times 2 to the 4, which is 16, which is 48, 480. And the answer is sum of all these things, 64 plus 384 plus 480. 0 plus 4 is 8. 8 plus 8, 16, plus 6, 22, we have 2. 2 plus 4, 6. 6 plus 3, 9. So the answer of this problem is 928. So look here, we've considered different cases. We split up the problem into different cases. Before AIME 2022, I released a video about preparation for AIME. In that video, I also before BMO for UK. I said important and general thing. One part was considering when you find a problem a little hard, you consider one property and divide the problem into different cases and solve the problem case by case. And also we solved different problems in AIME 22 with that idea. You should in Harvard MIT math tournament, in Stanford math tournament, always in all years, you need to know this idea, work on different cases. You should solve around, I can say, 10 important problems in this topic. Then you will get good at these problems. Okay, if you want to know the problems that are important for this topic, feel free to send message to my WhatsApp number in the description and comments. AIME II 2023, problem number 8, let omega equal to cos 2 pi over 7 plus I times sine 2 pi over 7, where I equal to square root of negative 1. Find the value of the product of k from 0 to 6. It is the sign of product. Means for you have you replace k0 to 6 here, then multiply all of them together. Omega to the 3k plus omega to the k plus 1. Okay. So let's solve this. At first, let's analyze a little. Omega is what? Let me tell you, if xn equal to 1, then you can say the root here is cos 2 pi over n plus I sine 2 pi over n. And you can also, for example, you can consider this r. Then the roots are r, r2, r3, r cubed, r to the n. Okay? Or you can say r to the n minus 1, and one of them is 1. Instead of r to the n, you can say 1. And sum of the roots is what? Always you can say 1 plus r squared plus r cubed plus r. You can use figures r to the n minus 1. It is equal to 0. It has two proofs. One proof is you say, okay, by Vieta's formula, we know xn minus 1 equal to 0. If you have an xn plus an minus 1 xn minus 1 to a1x plus a0, it has, for example, roots r1 to rn. Sum of the roots r1, let me write r1 plus r2 to rn, you can say it is equal to negative an minus 1 over an. And here, because an minus 1 is 0, that's the reason it is 0. Also, you can consider, for example, it will be as they will be around. But the next proof is more, we can say, intuitive. But also, you can say, for example, because it is 1, the next one, for example, 2 pi over 7 is r. Then you can say, for example, r squared, and all these things, r to the n minus 1. This view also good. For some problems you want to work a little intuitive thinking, it helps. And you can consider them like vectors, and then their sum will be 0. Okay? But Vieta's formula was so much better. So, here an minus 1, 0, so negative 0 over an, which is 1, negative 0 over 1 is 0. Now here, we conclude because omega is, because it is 2 pi over 7, 2 pi over n, we know that omega is root of x to the 7 equal to 1. We can say the roots are 1 plus omega squared plus omega cubed plus omega to the 4 plus omega to the 5 plus omega to the 6 equal to 0. Okay? So we have this, and if you subtract by 1, you can say omega squared, omega cubed, omega 4, omega 5, omega 6 equal to negative 1. And we will use this a lot of times in this problem. Now, let's calculate the problem. I think that problem once. Okay. So let's replace k with 0. It will be w0 plus w0 plus 1 times k equal to 1, w3 plus w plus 1, w2, w6 plus w2 plus 1, w3, which will be w9 plus w3 plus 1. If k is 4, w12 plus w4 plus 1. If k is 5, w15 plus w5 plus 1. w18 plus w6 plus 1. w to the 0 is 1, w to the 0 is 1, 1 plus 1 plus 1, 3. Now, look, if I write all of them in one line, let me rearrange them. One important thing that useful in round 1, AMC, also IMO. I can tell you exactly which IMO should use. If you want to know the IMO problem that you can solve with this idea, as I said before, feel free to send message to my WhatsApp number in the description and comments. It's Gauss idea. Gauss idea is what? The first thing that you should know. For example, if 1 plus 2, you want to calculate 1 plus 2 to 100 is what? You say it is 8. You say then I write it in reverse order. 100 plus 99 plus 1. Then if you add these two terms, 2a equal to 1 plus 100, 101. 2 plus 199, 101. Plus 100 times 1, 101. So a equal to 100 times 101 over 2. We call it Gauss idea. You consider first and last, second and second from last. And here we want to use exactly Gauss idea. Means what? We want to multiply these two things, then multiply, let me write the next with other color. Second and second from last, and the last case we want to multiply with red this and this. Okay? So let's see this word. At first, I calculate the green one. Means what? W cubed plus W plus 1 times W18 plus W6 plus 1. We know W is root of x to the 7. So W to the 7 equal to 1. Because x to the 7 equal to 1, W is root of this. So W to the 7 is 1. So W to the 18, we can say W to the 18 is W to the 7, which is 1 times W to the 7, 14 times W to the 4. So look, you can consider 18 mod 7 is 4. So we can say it is equal to W cubed plus W plus 1 times W4 plus W6 plus 1. Let's calculate. If we multiply W cubed to all of them, it will be W7 plus W9 plus W3, W to all of them, W5, W7, W. If we multiply 1, it will be W4 plus W6 plus 1. And then W7 we know is 1, W9 we know is W squared because W7 is 1, W3, W5, W7 is 1, W4, W6, plus 1. So here we have 1 plus 1 plus 1, 3. Plus W, W2, W3, W4, W5, W6, you have all of them. W plus W squared plus W cubed plus W4 plus W5 plus W6 equal to 3 plus minus 1. 3 minus 1 is 2. So the product of green 1 is 2. Now similarly, let's calculate the next parts. And you can write in general. For example, you can say, okay, W3, for example, something times, look, 18. Let me tell you. You can say, for example, W3K plus WK plus 1 times W3. Look, it is 3 times 6, 3 times 1. 7 minus K plus W7 minus K plus 1. And you can see the product is 2 in general. And we will also use that. But because we have only 3 cases and we've calculated 1, let's calculate the other 2 cases. Solution number 1 we can say, then I will tell you for in terms of K, if you want to find W6 plus W squared plus 1 times W15 plus W to the 5 plus 1. So we can write it as W6 plus W squared plus 1. Because W to the 7 is 1, W to the 14 is 1, so it will be W plus W5 plus 1. Now, if we calculate this, it will be W6, W7 times W plus W11 plus W6 plus W3 plus W7 plus W2, W1, W squared. Next one, 1 to all of them. It's W plus W5 plus 1. Okay. Now, W7 is 1, so it will be W4 plus W6 plus W cubed plus 1 plus W squared plus W plus W5 plus 1. Okay, so 1 plus 1 plus 1, 3 plus. You have W2, 3, 4, 5, 6. W squared to W6, which is negative 1 we've calculated. So 3 minus 1 is 2. On last part, we were written like this. W9, 3, 1, 12, 4, 1. W9 plus W3 plus 1. W12 plus W4 plus 1. Okay, so let's calculate this. And because W to the 7 is 1, we can replace W9 with W squared, W cubed plus 1. Instead of W12, we can write W5 plus W4 plus 1. Then we multiply W squared to all of them. It will be W7 plus W6 plus W squared. Then we multiply W cubed. It will be W8. Instead of W8, we write W1. Then W3 times 4 W7, we write 1. Instead of W7, W cubed times 1 W cubed plus we multiply 1 W5, W4, 1. Here also we can say it is 1. So it is 1 plus 1 plus 1, 3. Then you have W, W2, W3, W4, W5, W6. You have 1 from each of them, W, W squared to W6. It will be negative 1. So it will be 3 plus negative 1 equal to 2. So each of them will be 2, so 2, 2, 2. And you can say 3 times 2 times 2 times 2. 2 times 2 times 2, 8. 3 times 8, 24. Now let me explain for you solution number 2. If we want to, for example, for general things, we want to prove it is 2. Here, for example, it was AIME, and it is not, we can say, related to AIME because it is not full solution exam. We had only 3 parts, but sometimes you have 100 parts. And if you want to write, you should write for 50 times. In this problem, we've written for 3 times. Look, here, because we had 6 terms, we had 3 pairs, and we could calculate manually. But sometimes maybe you have, for example, 100 terms. In that case, you should write like this, general form. And let's analyze this. W, it will be what? W3k plus WK plus 1 times W21 minus 3k plus W7 minus k plus 1. So let's calculate it. W3k to each of them, the next one is W21, the next one is W7 plus 2k plus W3k. And when we multiply WK, it will be W21 minus 3k will be 21 minus 2k. The next one is W to the 7, the next one is W to the k. The last one is 1. You multiply W21 minus 3k plus W7 minus k plus 1. So W to the 7 is also 1, 1 plus 1. It will be 1 plus 1, 2. This one and this one. And W to the 27 also is 1. So let's write 1 plus 1 plus 1, 3. Plus. The other cases are W7 plus 2k plus W3k plus W21 minus 2k plus W to the k plus W21 minus 3k plus W7 minus k. And look, here because we were considering these, we should consider k 1, 2, 3. Okay, now I want to say 1, 2, 3, 4, 5, 6. I want to say one of them is W, one of them W squared, 3, 4, 5, 6 mod 7. So now let's focus on the powers. I want to say 7 plus 2k, 3k, 21 minus 2k, k, 21 minus 3k, and 7 minus k. I want to say all of them different. Mod 3, mod 7. Mod 7, they are different. And also they are not equal to 0. So if we say this, then we have 6 terms. They will be W1 to W6. It will be negative 1 and it will be 2. So why mod 7 they are different? Let's consider mod 7. If 7 is 0, you can get rid of that. Minus 2k. K. 21 minus 3k. It will be negative 3k. 7 minus k minus k. And because we can add 7k to the negative parts, it will be 2k, 3k, 7k minus 2k, 5k, k. 7k minus this 4k, and 7k minus this is 6k. So it will be what? K, 2k, 3k, 4k, 5k, 6k. We know if ik is congruent to jk mod 7, then you can divide both sides by k. And we know because k is 1, 2, 3, I is congruent to j mod 7 over gcd of 7 and k. The formula is this. GCD of 7 and k is 1, so it is this. So I, because I and j are from 1 to 6, I equal j, so contradiction. So all of them are different. So we can say mod 7 they are equal to 1, 2, 3, 4, 5, 6. So this part is -1. So 3 minus 1 is 2. And with this way, you say, okay, it is 2, so it is 2, 2, 2, 3 times 8, 24. Okay, so 3 times 2 cubed equal to 24. If you had question about this problem or wanted to learn more things, like combination of Vieta's formula and complex numbers are so much interesting, and you can use these two things and a lot of other things, combine them and reach a lot of important conclusion. If you want to know important things that are useful in AIMC, AIME, other levels, as I said before, feel free to send a message to my WhatsApp number in the description and comments. Problem number 9, AIME II 2023. Circles omega 1 and omega 2 intersect at 2 points P and Q. Let me draw. Okay, omega 1, omega 2 intersect at 2 points P, Q, and their common tangent line closest to P intersects omega 1 and omega 2 at points A and B. So let me draw. Okay, it is this line, the line parallel to AB that passes through P. This one intersects omega 1 and omega 2 for the second time at point X and Y. Okay. Okay, so this line is parallel to AB, XY. This is parallel to this one. And then it says, suppose PX is 10. So this is 10, PY is 14, and PQ is 5. So I've extended PQ, I will tell you why it's important. And PQ is 5. And then it says, then the area of trapezoid XABY. XABY equal to m root n, where m and n are positive integers and n is not divisible by the square of any prime, and m plus n equal to what? Okay, let's calculate. At first, I should tell you something. If you have a circle and you have a common tangent, or you have a tangent to the circle, if we connect O to the tangent point, the angle is 90. Now here, if you want to consider O1, O2, okay, here we consider is O1, so if we connect, it is 90 degree. And also we can conclude it is 90 degree because these two lines are parallel, X, Y, and AB. And in a circle, if O, for example, it is a chord, if O, a radius is perpendicular to this, then these two lines are equal. Why? Because the proof is, you can say, O, this is radius, these two triangles are congruent, then these two things are equal. Or it is isosceles triangle, altitude is also median. So here we conclude this is equal to this, so because it is 10, we can conclude this part, let me show you, this part is 5, this part is also 5. Now, we do the same thing for this part, circle omega 2. Okay, we call this one O2. We know it is 90 degree, it is 90 degree, then 14. It is perpendicular bisector of BY, so let me erase. So this part is 7, this part is 7. Now, another thing. If we draw perpendicular bisector of PQ, it passes through O1 and O2. If you don't know these things, the things I'm using are basic things. If you don't know these things, the basic things and also professional things, 40, 50 important formulas that are useful for also US IMO, AIME, AIMC, IMO. If you want to learn them, feel free to send message to my WhatsApp number in the description and comments. Okay. So we have, for example, PQ also, you can say it is 5 over 2. We are analyzing the problem 5 over 2. Now, let's call this one, you have AB, let's call this one C. I want to prove C is midpoint here. So, let me tell you, the proof is what? At first, I should tell you an important rule. that if you have, for example, P, if you have A, this P is not related to the P in the problem. It is a lemma, a point. PA squared, for example, is C. PA squared equal to PC times PB. Okay? And here we can say CA squared equal to, let me tell you, CA squared for omega 1, if you consider, is equal to CP/CQ. If you consider omega 2, CP/CQ equal to CB squared. So because CA squared equals CB squared, CA equal to CB. So we conclude this length equal to this length. Now, because it is this is rectangle, let me call this one ABCDE. ABDE is rectangle, okay? Because we have all angles are 90. So we conclude AB equal to ED. ED equal to what? Look, AB, this is rectangle. Because all angles are 90, 90, 90, 90, 90. Now, AB equal to ED. ED is what? 5 plus 7, 12. And because AB then it will be 12, then C is midpoint of AB. So it will be 6, it will be 6. And let me tell you, always when you want to solve a problem like this, focus on both assumptions and sentence. Here we've worked something, we've analyzed assumptions and sentence. Now in next step, we want to find what? Area of this trapezoid. So we should find, for example, this height times this plus this over 2. So it will be what? For example, AE times AB plus XY over 2. And it is AE. AB is what? Is 12. XY is what? Is 10 plus 14. Look, 10 plus 14 equal to 24 over 2. 12 plus 24 is 36 over to 18 AE. So the only thing we should find is AE. Now here, because we have 90, we should pay attention. Can we use any Pythagorean theorem here? Here, if you consider this trapezoid, AEPC, let me show you. This strategy also useful. For example, when you see A, it is 90. For example, this one, and then this one. Okay. So it is what? It is C, it is P, it is E, it is A. It is 90, it is 90. Okay. Now, here, if we draw this one, AE, suppose for example AE we call it H. So because it is H, it is H. EP is what? 5. AC is 6. But because they are parallel and it is 90, it is 5, it is 1. So if we find CP, then we can find H. We want to find 18 times AE is H. So we should find CP. And now by this one, we know CP times CQ, like here we've written, equal to CA squared. So CP times CQ equal to CA squared. CA squared is 36. And we can say CP instead of CQ, we can write CP plus PQ. Okay, CP times CQ is CP plus PQ. PQ is 5. So we can say 36. PQ is 5. So CP squared plus 5CP. We take 36 to left hand side equal to 0. Now we factorize. CP, CP. So 36, we can say plus 9 minus 4. So CP, the first one is 0, negative 9, or 4. Negative 9 is negative, CP is length, it's not possible. So CP is 4. Now we can easily say H squared equal to 16 minus 1 equal to what? Equal to root 15. So the answer is 18 root 15. So M is what? Because we are working with M and N, it is 18 root 15. So M is 18, N is 15. Their sum is 33. Okay, so the answer of this problem is 33. If you had question, or wanted to learn, as I said, 40, 50 important formulas, this one can solve IMO problem with this point. And how to find this in a problem, how to use contradiction, how to change the assumptions, the formulas in angle bisectors, perpendicular bisectors, altitudes, orthic triangles, all these things. If you want to learn them completely, as I said before, feel free to send a message to my WhatsApp number in the description and comments. Problem number 10, AIME II 2023. Let n be the number of ways to place the integers 1 through 12 in the 12 cells of a 2x6 grid so that for any two cells sharing a side, the difference between the numbers in those cells is not divisible by 3. One way to do this is shown below. Find the number of positive integer divisors of n. Okay, so look, it says the difference shouldn't be divisible by 3. So if we consider the numbers, for example, 1 with 4, the mod 3 is 1, the remainder is 1. 7, 10. These numbers in next step 2, 5, 8, 11, and in last step 3, 6, 9, 12. So for example, 1, 4, 7, 12 shouldn't be adjacent. 2, 5, 8, 11 shouldn't be adjacent. 3, 6, 9, 12 shouldn't be adjacent. And look, because 1, 4, 7, 10 are similar, you can consider all of them as 1. Means we have 4 ones. Here means we have 4 twos. Here means we have 4. Instead of 3, we write zeros. We should place them 4 ones, 4 twos, 4 zeros in the table, and at the end, in the places of 4 ones, we multiply it by 4 factorial. How to arrange, how to place 1, 4, 7, 10 in the places that we have 1. Then 4 factorial for twos, 4 factorial for zeros. Times. Now, ones shouldn't be adjacent, twos shouldn't be adjacent, zeros shouldn't be adjacent. Now, if we consider the columns, okay, the columns can be what? 0, 1 or 1, 0, or you can switch. The next one, 0, 2. Again, you can switch. And the third one is 1, 2, the only possible case. Now, for example, suppose we have A from this, B from this, C from this. Okay? Because the number of zeros is 4, A plus B should be 4. Because of number of zeros. Because of number of ones, A plus C equal to 4. Because 2's are 4, which sum is 4, 2, 2. B plus C is 4. Now we want to say that from these three equations, we can conclude ABC equal to 2. If we subtract these two equations, A minus C equal to 0. So A equal to C. Let's check A. Sorry. B minus C if we subtract. A will be cancelled. B minus C equal to 0. So B equal to C. Because B equal to C, if we combine with this, 2B equal to 4. So B equal to 2. Also C equal to 2. And if we replace here, A plus 2 equal to 4, A equal to 2. So we have 2 of these types, 2 of these types, 2 of these types. Okay. Now, if we say, for example, look, each of these two things have one thing in common. For example, A and B, this type, 0 is in common. This, the first one, last one, 1 is in common. Second one, last one, 2 is in common. So, if we consider, for example, one of them, first one. Suppose, for example, we have, let me consider T1, consider T2, type 2, type 3. And we need 6 columns. Suppose we have 2 T1s, for example, suppose it is T1, T2, T2, T3, T1, T3. Okay, then I want to say it will be unique. Why? Let's check. When it is T1, if you determine the first one, if you determine T1, for example, it is 0, 1 or 1, 0. Okay, so because it is 0, 1, then T2 is 0, 2 or 2, 0. It should be 2, 0 because zeros are not adjacent. The next one, T2, it should be 0, 2. T3 1 2 2 1, it should be T1 0 1, it should be 1 0. T3 1 2, it should be 2 1. And for pink one, it is 1 0. T2 should be 0 2. The next one should be 2 0. All of them will be switched. 1 2. The next one 0 1, and the last one 1 2. Okay. So here, for arranging T1 to T6, T1 we have two T1s, two T2s, its permutation with repetition, 6 factorial, 2 factorial, 2 factorial. It is because we have two T1s, two T2s, and two T3s. And then you should determine the first one. The first one is what? For example, if it is T1, it is 0 1 or 1 0. And you multiply it by 2. So the problem says what? The problem says n is this, and it says that find the number of positive integer divisor of n. So let's first prime factorize n. 6 factorial is 720 over 2 factorial. 2 factorial, 2 factorial is 8. 720 over 8 is 90. 90 times 2 is 180. So let's write like this: 90 times 2 times 4 factorial is what? 24. Is 8 times 3 cubed. So 90 is what? Is 2 times 45 is 2 times 9 times 5 times 2 times 8 is what? 2 cubed times 3 cubed. So here the power of 2, 2 squared here we have, because of these two, 9 is 3 squared times 5 times 2 cube is 2, 3 times 3, 9 times 3 cubed. Now the power of 2 is 2 plus 9, 11 times 3 to the 5 times 5 on 2 to the 9, we've considered that. Now let me tell you how to calculate number of positive divisors. Look, if you have a divisor, the power of 2 can be 2021 to 2 to the 11. So it has 12 cases. That's the reason they say consider the powers when you prime factorize them, plus 1 of each of them, and multiply them together. For 3, it will be 30, 31 to 3 to the 5. So it will be 5 plus 1, 6 cases, and 50, 5 to the 1. It will be 2 cases, so 12 times 6, 72. Times 2, it will be 144. So n has 144 positive divisors, and the answer of this problem is 144. So look, we've considered different cases, we've analyzed completely how to understand. Also in BMO 2, round 2, we had a problem that you should consider all numbers with only 0, 1, 2. BMO is for UK, round 2 is like, we can say the difficulty is similar to USAMO. If you want to learn how to apply it in invariant, the problems need invariant. As I said before, feel free to send a message to my WhatsApp number in the description and comments. Problem 11, AIME II 2023, find the number of collections of 16 distinct subsets of 1, 2, 3, 4, 5 with the property that for any two subsets x and y in the collection x intersect y is not null set. For this problem, we should use an important, so much important point. Consider groups. Look, considering groups also in IMO, it can solve many problems of IM. Means what? Look, if you consider the subsets of 1, 2, 3, 4, 5, we have 2 to the 5 because each element comes or doesn't come. 32, we have subsets. We consider, for example, null set with 1, 2, 3, 4, 5. Look. Complement set. So we consider, for example, 1 with what? With 2, 3, 4, 5. We write these things. We consider 2, 3, 4, 5. And each group has two subsets: 1, 3, 4, 5. The next one is 1, 2, 4, 5. Look, if you solve some problems, you don't need to write all of them. You can imagine many of them. But because I want to tell you a solution that all students understand, I will write all of them. So 1, 2, 3, 4. Now we have subsets that contains 2 elements and 3 elements. So let me erase this part. We know 2 to the 5. We can write it here, 32. So the next one is 1, 2, 1, 3, 1, 4, 1, 5, 2 3s, 2 4, 2 5, 3 4, 3 5, and 4 5. Okay, so because if 5 choose 2 is 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We've not forgot any of them now. For example, 1, 2, it will be 3, 4, 5. For 1, 3, we have 2, 4, 5. For 1, 4, we have 2, 3, 5. For 1, 5, we have 2, 3, 4. For 2, 3, we have 1, 4, 5. 2, 4, 1, 3, 5. 2, 5, 1, 3, 4. The next one, 1, 2, 5. The next one, 1, 2, 4. And for last one, we have 1, 2, 3. Okay, now in this step, okay, now first we should select 16. So look, it is first one, second one, third one. The last one is 16. Okay, fourth one, fifth one, sixth one, seventh, eighth, ninth, 10th, 11th, 12th, 13, 14, 15, 16. Okay. So look, from each group you should exactly select one of them. Why? Because you can't select 2 of them because their intersection is null set. So, and because we need 16, so from each of them we should select exactly one. If you don't select from one group, then we have at most 15. Okay, now here let's consider these from 2 to 6. They are sets with 1 element. So I want to see from 1 element how many I select. So suppose the number of, for example, elements with subsets with 1 element that we select. We can't select 2 of them because if you select, for example, 1 and 3, 1 and 4, then their intersection is null set, and that's contradiction. So we say we select 1 of them or we select none of them. If you select from 1 of them without loss of generality, you have 5 cases. For example, without loss of generality, you select 1. Then here you should select this. In each group, only one of them contains 1. For example, here, this, and this. Okay, so the rest will be unique. So 5 times 1. So it will be 5. Now consider that we don't select any of the subsets that contain 1 element. So we select this one. Also, we shouldn't select null set. This one, and we don't select these things. Okay, now let's focus on here. 1, 2, 1, 3, 1, 4 here. Now we consider. So look, considering different cases exactly before the day of AIME 12/8, 2022, I released a video preparation. I said you should consider different cases for problems like this. Then if one part was hard, again focus on another property and consider another case. Splitting to different cases. Here I consider the number of subsets with 2 elements. So here, in first case, we say we don't select any of them. We select 1 of them, 2 of them, 3 of them, 4 of them, and I prove for 5, and so on, all of them will be 0. So let's select first 0. If we don't select any of these things, so we select only elements, subsets with 3 elements, and because all our subsets contains more than 2 elements, so they have intersection, because when you have 3, you have 5 elements in all. 3, if they don't have any intersection, then we need 6 elements, but we have 5 elements. So then if we don't have any subsets with 2 elements, is one way, and it works all subsets with 3 elements, 4 and 5 elements. Now, consider we select 1. For example, we select 1 and 2. Okay, so for example, we select only 1 and 2 here, and the others like this. And look, all of them contains 1 or 2, because if they don't contain 1 and 2, it will be 3, 4, 5, and we've not selected that. So the rest will be unique. But 1 and 2, how many do we have from 7 to 16? 16 minus 7 plus 1 will be 10. Or you can say 5 choose 2 times the rest will be unique. The subset that we select, 5 choose 2, is 10. Now let's analyze the case that we have 2 cases. So one of them 1, 2. The next one should have intersection with 1, 2. For example, without loss of generality, consider 1, 3. Okay, so we've selected 1, 2, 1, 3. Now, because from others we select all these things, they have intersection, because 1, 2, the only subset with 3 elements that doesn't have intersection with this is 3, 4, 5 with others. Okay, this. So how we can select 1, 2, 1, 3? We say, okay, at first we select 1, the element that is in common in these two sets. So we will say 5 choose 1. Then you should select, for example, 2 and 3. 4 choose 2. Okay, so if we calculate this, it will be 5 times 6, 30. Okay, now we want to consider when we have 3 subsets with intersection 2, 3 subsets with each of them has 2 elements. So we have 2 types for 3. One type is for 3, one of them you say, okay, 1, 2, for example, 1, 3, 1, 4 is one type. The other type is, you say 1, 2, we don't have an element in all of them. So for example, if next one is 1, 3, the next one is not 1, 4, it can only be 2, 3. So if you focus on this, and look, if you select, the rest will be unique, which you should select subset with 3 elements. So you should select 1 for 5 choose 1 times 4 choose 3 for 2, 3, 4. So 5 times 4, 20 plus the next one. You say, okay, 1, 2, 1, 3, 1, 2, 3. So look, you should select 3 elements, and you say, okay, 1, 2, 2, 3, 1, 3. So we say here 4 choose 3, which is 4. I'm sorry, because we have 5 elements, 5 choose 3. Let me write it here, plus 5 choose 3, which will be 10. Okay. Now 4, let me not write plus, is 10. For 4, the only possible case, let me erase this part, is, for example, you select 1, 2, 1, 3, 1, 4, 1, 5. Okay? We should have one element in common. So you say which of them you select. 5 choose, for example, 5 choose 1 for 1, which of them is in common, and then you should select all others 5. And here for 5 you can't select, because 1 can come only with 4, the next one doesn't contain 1, and we have problem with at least one of them. So for 5 and rest will be 0. Now let's add all these things. Let's go here, okay. So 5 plus 1, 6, plus 10, 16, plus 30, 46, 66, 76, 81. So the answer is 81. Okay, so we could also imagine these things, but the most important thing with considering cases without any spatial creativity, we can solve these types of problems. Maybe if we think we can find some solutions that are easier and you can reach in a faster way, but you should learn. You have to learn considering different cases, finding a property. And look, because I want to explain, it takes time. But if you learn how to solve, you can quickly analyze these things and reach the correct answer. And there are lots of problems in AMC, AIME, and other levels that you have to use a property and consider different cases. Okay, if you had questions or how to solve these types of problems, we have a lot of problems like this in subsets, different sets. And as homework, for example, you can say how many For example, suppose x and y are subsets of 1 to 5. How many x and y are there such that xy is null set? So you can solve it as homework. And we have lots of other things, 3 elements, k elements, some of the things. You can also say someone says sigma x intersect y. Calculate these x and y are subsets of 1 to 5. You can calculate these things and comment your answers right below this video if you want to know how to solve this problem and also harder problems. They are related to double counting. As I said before, feel free to send message to my WhatsApp number in the description and comments. AIME II 2023 problem number 12. It says in triangle ABC with side length AB 13, BC 14, CA 15. Okay, let's draw. Okay, AB is 13 here, CA is 15, and BC is 14. Okay, let M be the midpoint of BC. So this is M, midpoint, because BC is 14, so it will be 7. It will be 7. Let P be the point on the circumcircle of ABC, triangle ABC. So let's draw the circumcircle of triangle ABC. Okay? It says let P be the point on the circumcircle of ABC such that M is on AP. Okay, M is on AP and P is on circumcircle, so it will be something like this, and this one is P. Okay. There exists a unique point Q on segment AM such that PBQ, let's consider for example it is Q, PBQ equal to PCQ. Okay, let me draw this. So it is Q, this angle equal to this angle. Now it says then AQ can be written as M over root N, where M and N are relatively prime. Positive integer M plus N equal to what? Okay, first we want to use sign law, and also I want to tell you ratio lemma. And the ratio lemma, the name is not so much famous. You can prove it with two sign law. We can call it double sign law. Ratio lemma, it's so much useful in many problems. Let me tell you is what if we have a triangle and for example we have any point here, it is ABC. For example, it is Q. Okay, it is not this Q. Let me for example call this K. Sine A1, A2. Sine A1 over sine A2 equal to BK over CK times sine B over sine C. And also instead of sine B over sine C, you can say BK over CK times B over C. And the proof is you should use two sine law. One in ABK, one in ACK, and use them and you can easily reach this. So proof is as homework. If you had question, feel free to send message to my WhatsApp number in the description and comments. Also, if you want to learn important things like this. Now, here it is AK and we have this line. So if you consider, let's say for example it is alpha, it is beta, okay? And also because of alpha, this arc, it is inscribed angle is 2 alpha, this arc is beta equal to 2 beta. So this angle you can say is beta also. Let me write it like this. You know, it is equal to this. This angle is beta. This angle is alpha because they see this arc and this arc. And BM is 7. MC is also 7. So if you use ratio lemma here, sine alpha over sine beta equal to BM over CM times B over C, which is 15 over 13. BM, CM are equal, so we conclude sine alpha over sine beta equal to 15 over 13. It is the first thing we've reached. Let's call this equation equation 1. Now, if we consider sine law in triangle BPC, then we can say what? We can say BP over sine alpha equal to PC over sine beta. So we can say sine alpha sine beta equal to, look, sine alpha times PC. So we should write BC sine beta BP. By first one, we know sine alpha over sine beta is 15 over 13. So BP over PC equal to 15 over 13. So we can write BP equal to 15x, PC equal to 13x, because the ratio is 15 over 13. Now we know this is angle C, so this arc is 2C. This is angle B, so this arc is 2B. So here we can say this is B because of this is 2B. This is C because of it is 2C. Now we use sine rule to sine law again. Exactly before the day of AIME 12A and 10A, I released a video and I told important things: sine law, double sine law, ratio lemma, these things. You should be able to use them. Now, the next one, I use sine law in two triangles, in triangle QBP and also in triangle QCP. So if we use in QBP, we can say QB over sine C equal to, let's call this angle theta, theta, they are equal to QP sine theta. And here you can say QC over sine B in triangle QCP equal to QP over sine theta. Because QP over sine theta in both of them equal, so we can say QB sine C equal to QC sine B. And then you can rearrange, you can say QB QC, look, QC sine C, so it will be sine C, QB sine B, sine B. And if we use sine law, it will be C over B. C is what is 13, B is what is 15, 13 over 15. Now we can say QB is 13y, QC is 15y. Okay. Now here I want to prove y equal to x. How? If we use cosine law in BPQ, so look, here we can say 13y squared plus 15x squared minus 2 times 13y times 15x cos theta equal to qp squared. Okay, it is why? It is because of cosine law in triangle BQP. Now if we use cosine law in triangle CQP, we can say 13x squared plus 15y squared minus 2 times 15, for example, 13x, 15y cos theta again equal to qp squared. Now, so because both of them qp squared, they are equal, and this part equal to this part. Because both of them will be 2 times 13 times 15 xy. Now we can conclude 13y squared plus 15x squared equal to 13x squared plus 15y squared. Now, 13y squared is 169y squared. 15x squared is 225x squared. 13x squared is 169x squared. This one is 225y squared. Now, 225 minus 169 is 15 minus 9, 6. And then it will be 1, 12 minus 11 minus 6, 5. And then it will be 1 minus 1, 0. So 56x squared. Again, here you can conclude 56y squared. So x squared equal to y squared and x equal to y. Okay, now we can erase all y's and replace them with x. Okay. 13. So let me draw new figure. Okay, now we conclude what triangle BQC is congruent to triangle BPC. Why? Because of three sides. Okay, all three sides are equal. So we can say because it is beta 13x, it is 13x, it is also beta. Let me show it is also beta. And because it is alpha c is 15x, here it will be alpha. So theta is beta plus alpha. We can erase theta. Now we found all these angles. Now here, we want, look, it has several solutions, but one important solution, and it has a so much important point. If you have, for example, these two angles equal, for example, it is gamma, this angle is also gamma, and for example, it is ABC and it is P, then PA is tangent to triangle, a circumcircle of triangle ABC. And we have PA squared equal to PB times PC, and you can say, we can use similar triangles, PAB, PAC. And it is equivalent that angle PAB equal to angle PCA, okay? These two angles are equal, so we have this point. It's so much important point. Now, if you use here, this angle equal this angle, so MC squared equal to MQ times MA. So MC squared equals to MQ times MA. MC squared is 49 equal to MQ times MA. Now we want to find MA. MA is median of ABC. It has a formula itself. You can also use Stuart's theorem, but MA squared, memorize this. It's useful. MB squared over 2 plus C squared over 2 minus A squared over 4. As I said, there are 40, 50 important formulas. You can learn, for example, it is in median, in altitudes. We have a lot of formulas, and they help you in exam. Also, Stuart's theorem you can use, and you reach same result. B squared is what? It's 15 squared over 2, plus C squared is 13 squared over 2, minus A squared over 4, which will be 14 squared over 4. 15 squared is 225, 13 squared is 169 over 2. 14 over 2 is 7, so it will be minus 49. If you add these two things, 9 plus 5, 14, we have 1, 6 plus 2, 8 plus 1, 9, 2 plus 1, 3. 394 over 2 is 1, and 19, 9, 14, 7, minus 49. Now, 17 minus 9 is 8, 8 minus 4, 4, 1, 4, 8. So MA squared is this, so MA equal to square root of 1, 4, 8. Now, here, if we replace, it will be 49 equal to MQ times MA. We'll replace it with 148. So we can conclude MQ equal to 49 over square root of 148. Now, the problem says AQ is what? AQ is AM, which is square root of 148, minus MQ, which will be 49 over square root of 148. Now, if we simplify, it will be square root of 148. Square root of 148 times square root of 148. 148 minus 49 is 99. So it says now m plus n is what? It is m over root n. So the answer, let me write with other color, is 99 plus, let me write outside here, answer is 99 because it is m over root n. The problem says, right? M over root n. And m and n are relatively prime, obviously. It's multiple of 9 and 11. It's not multiple of 9 and 11. So it will be 99 plus 148, which will be 247. Okay, we solved this problem completely. It has a lot of other ways. But in all problems, you should use angle chasing, sine law, cosine law, ratio lemma, which is, we can say, double sine law. And we have also double Pythagorean theorem that is so much useful. If you want to learn them, as I said before, feel free to send message to my WhatsApp number in the description comments. AIME II 2023 problem number 13. Let A be an acute angle such that tangent A equal to 2 cos A. Find the number of positive integers n less than or equal to 1000 such that secant n of a plus tangent n of a is a positive integer whose units digit is 1. Okay, so suppose we consider this, for example, an. Let's consider a1 first, or a0, for example. a0, it says n positive integer, but let's calculate also this. It will be secant 0 to the a plus tangent 0 to the a. Okay, so it will be 1 plus 1, 2. Now the next one. a1 is secant of a plus tangent of a. Okay, so a1 is secant a plus tangent a. You can say it is equal to 1 over cos a, because look, we can consider cos a equal to x, sine a equal to y, so cos a equal to x, sine a equal to y. So first one, tangent a is sine over cos y over x equal to 2x, so we conclude y equal to 2x squared. Now here is 1 over cos a plus tangent a is sine a over cos a. Also in general we can say an. You can say 1 over cos a to the power of n, 1 over xn plus yn over xn. It is y1 plus yn over all over x to the n. Okay, now here we can replace it. We can say it is 1 plus y over x. Okay, so we can calculate because by this, because we know x squared plus y squared is 1. We can calculate x and y, and we can replace here. We can find a1. But let's do something. For example, an is what? Is 1 plus yn over x to the n. So let's do something. For example, if I multiply 1 plus y, let's see how can we write. I think it's better to write like this. Y 1 over x and not use common denominator. So if we use, for example, a1, 1 over x plus y over x, and if we multiply it by 1 over xn minus 1 plus y n minus 1 xn minus 1, it is what? It is a1 times an minus 1. Let's see what happens. 1 over x times 1 over xn minus 1 is 1 over xn, plus second times second is y to the n xn. First times second will be y to the n minus 1 xn. Second times first is y over x to the n. And this part we know is an. Sorry, here is an minus 1 is an. And this part is what? We can factor from y over x, then it will be yn minus 1, xn minus 1 plus 1 over xn minus 1. Now we can conclude. It is what? This part is again an minus 1. Y over x is what? We know that y equal to y over x is 2x. It is an minus 1. And because we factored from y, no, sorry. It is n minus 2. Because it is n minus 2 and we want to use an, we factor from x squared. Okay, so if we factor from x squared, they will be also n minus 2. Okay, so if we factor from x squared, it will be n minus 2x n minus 2. So it is an minus 2. Y over x squared, because of this, is 2. Because y is 2x squared. So, for example, from this part, we conclude a1 an minus 1 equal to an plus 2 an minus 2. So it's good we found a relationship. So we can conclude an equal to a1 an minus 1 minus 2 an minus 2. Okay? Now let's do something. Here, it was 1 degree, it was n minus 1. If we use, for example, for any m, so we say y to the m over x to the m times 1 over xn minus m plus y over n minus m over xn minus m. So if we multiply first plus second, it will be 1 over xn plus y to the n over x to the n plus first one times second one will be y to the n minus m. xn, second one times first one, y to the m times x to the n. Okay. Now here we know it is am, it is an minus m. Look again, by considering a small example, we can generalize it. This part will be an, and this part, because I want to factorize, I don't know, n minus m is greater or m is greater. Without loss of generality, you can say m is less than or equal n minus m. Okay, then we can factor from ym, and so it will be 1 over, it will be n minus 2m. Like here, if we factor from ym and x2m, so the first one will be yn minus 2m over xn minus 2m plus 1 over xn minus 2m. And it will be what? It will be an minus 2m. And because y is 2x squared, so this part will be 2x squared to the power of m over x to the 2m. So this part is 2 to the m. Now, if we rewrite it, it will be am times an minus m equal to an plus 2 to the m times, from assumption of the problem, we know that y is 2x squared. So y over a, if you replace, then you will see it's 2 to the m times an minus 2m. Now we can conclude an equal to an minus m minus 2 to the m, an minus 2 to the m. So we call this equation equation number 1. Now let's consider a0 is 2, and let's calculate a1 and the other terms. a0 is 2. a1, if we want to use here, it's not possible. It will be a, for example, 0 times a1 minus 2 a1. Okay, so for a1, we know that we should calculate 1 over x plus y over x. And we know what y equal to 2x squared, y squared plus x squared equal to 1. Okay, now for this part, we can also replace y with 2x squared, so it will be 1 over x plus 2x. So we should calculate x is 1. Here, at first, let's calculate y. Then we can say y squared plus, instead of x squared, we write y over 2 equal to 1. Then if you multiply by 2, it will be 2y squared plus y, and take 2 to left hand side, minus 2 equal to 0. Then y equal to negative 1 plus minus. Let's consider square root of 1 minus 4 times negative 2 times 2. It will be 17 over 2. Because y is less than 1, because y is sine a. So if you consider negative, less between 1 and negative 1. If you select negative 1 minus root 17 over 4, it will be less than negative 1, and that's a contradiction. So because y is greater than or equal to negative 1, we can conclude y equal to negative 1 plus root 17 over 4. Now we want to calculate x. We know that 2x squared equal to y. So, or let's use these parts. We know y squared, which is negative 1 plus root 17 over 4 squared plus x squared equal to 1. Now we conclude x squared is 1 minus negative 1 plus root 17 over 4 squared. So it will be, if we factor from 16, it will be 16 minus 1 plus 17, 18 minus 2 root 17. And then x squared will be 16 minus 18 minus 2 plus 2 root 17 over 16. So because it says x is the angle A is acute angle, so cos A and sin A here, acute angle, sin A cos A should be positive. They cannot be negative. So when we consider square root, we can say okay, x is square root of, we can say 2 root 17. Let's write like this: 2 root 17 minus 2 all over 4. Now we want to calculate what? We want to calculate A1. A1 is the hardest part that we want to calculate. A1 is 1 over x, so it will be 4 over 2 root 17 minus 2 plus y over x plus 2x, we can say. It's 2 root 17 minus 2 all over 4. Now, if you use common denominator, it will be 4 square root of 2 root 17 minus 2. 4 times 4 is 16, plus the product will be 2 root 17 minus 2. So it was 16 minus 2, 14, plus 2 root 17 all over 4 times 2 root 17 minus 2. Now if you divide both numerator and denominator by 2, it will be 7 plus root 17 all over 2 times square root of 2 root 17 minus 2. Sorry, here, because we have 2x, I should change it to 2. So let's simplify. Let's erase this part. So look here, we consider 2 because it is 2. Then 2 times 4, 8. Plus 2 root 17 minus 2. So 8 minus 2 is 6. 6 plus 2 root 17. Here 2, you can cancel. Divide both numerator and denominator by 2. It will be 3 plus root 17 over this. Now we rationalize. We multiply both sides. Let me write first this. Square root of 2 root 17 minus 2. We multiply both numerator and denominator by 2 root 17 plus 2. Square root of 2 square root of 17 plus 2. Then denominator will be square root of 4 times 17, 68 minus 4. And numerator will be square root of 3 plus root 17 over 2 root 17 plus 2. Okay, so the denominator is 68 minus 4 is 64. Square root of that is 8. The numerator will be 3, 9 plus 17, 26. Plus 6 times root 17 equal to 2 root 17 plus 2. And then we can divide both numerator and denominator by 2. Because you didn't divide the numerator by 2 when it goes inside square root, you divide it by 4. You divide each bracket with 2, it will be 3 plus 13 plus 3 root 17 times root 17 plus 1. And then it will be square root of 13 root 17 plus 3 root 17, 16 root 17, and sorry, we divide by 8 by 2, it will be 4. 16 root 17 and 13 plus 3 times 17. It will be 13 plus 51 all over 4. So it will be 16 root 17 plus 64 over 4. So we divide both numerator and denominator by 4 because it goes inside square root. We should divide inside square root by 16. And it is 17, so it will be root 17 plus 4. So A1 is this, okay? A0 was what? A0 was 2. A1 is root 17 plus 4. Now the rest of AIs, we can use this recursive sequence. Let's copy. Okay, now we want to find A2. You consider N2, M1, okay? So it will be A1 times A1 minus 2 times A0. So it will be A1 squared minus 2A0. A1 squared is root 17 plus 4. Minus 2a0 is minus 4. You can cancel. It will be root 70. Okay. So a2 is root 70. a3, for example. a3 is what? You can say a2, m is 1 again, and 3. 1 a2 minus 4 or minus 2 a3 minus 2 a1. Okay. a1, you can factor from a1, it will be a2 minus 2. a1 is what? Root 17 plus 4. a2 minus 2 is what? Root 17 minus 2. Now let's calculate a4. We can consider m2, so n is 4. So it will be a2 squared minus 4a0. a2 squared is 17 minus 4a0 minus 4 times 2, 8. It will be 17 minus 8, 9. Okay, so a4, a3, we've calculated a3. a4 is 9. Let's calculate, for example, a5. Okay, here you can say m is 1, so it will be a1. a4 minus, for example, it will be 2 times a. 5 minus 2, 3. Okay, so a1, a4, it will be root on, because a4 is 9, you can say 9 square root of 17 plus 4 minus 2a3 will be minus 2 times square root of 17 plus 4 square root of 17 minus 2. Then it will be square root of 17 plus 4. Then 9 minus 2 times square root of 17 plus 4. Okay, so here we will conclude that a5 equal to square root of 17 plus 4. 9 plus 4, 13 minus 2 times square root of 17. Okay. Now in next step, when we consider a6, you can consider m2, so it will be a2, a4 minus 4 times a, 6 minus 4, 8. Okay. So a2 is what is root 17? a4 is what? 9. 9 root 17 minus 4 root 17. It will be what? 5 root 17. Calculate, for example, a6. We are just analyzing the problem, okay? a7 is what? We can calculate a7, for example, a8, and so on. If you calculate a7 exactly, let me tell you, you should replace m with what? You should replace m with 3, for example. Also with other ways you can reach. In this case, it will be square root of 17 plus 4, if you simplify, times 9 square root of 17 minus 26. And if you calculate a8, for example, you can say m is 4. You can say a4 squared minus 16 a0. a4 is what? a4 is 81 minus 16 a0. 16 times 2, 32, 49. So we will see, okay, a8, a4, a0. They are integers. At first, we should focus on ai's that are integers. So then we can conclude what you can prove it's not hard. Also, you can combine induction. We can prove that an is integer if and only if 4 divides n. Okay, and we should. If you had problem with proving this, feel free to send message to my WhatsApp number in the description and comments. Okay. Now we use this relationship that we have an. Like we have this. Now we consider, for example, n is 4 cubed. Okay. And we can consider, for example, m is 4. Okay. So a is 4q, a4q equal to a4q. Because m is 4, a4 times a 4q minus 4, which is 4q minus 1, minus 2 to the m, or 2 to the 4, you can say minus 16, a n minus 2m, so it's 4q minus 2. Okay, look, a4 is what? a4 is 9, so it is 9a 4q minus 1 minus 16a 4q minus 2. Okay. So we know, and because we want to consider mod digits, so we consider only mod 10, okay? A0 is what? And if you consider mod 10 here, you can say it is negative A4Q minus 1, minus 7, minus 6. You add by 10, A4Q minus 2, so you can say it is equal to negative A4Q minus 1 plus 6A4Q minus 2. Okay, so A0 is what? A0 is 2. A4 we said is 9. Now, if we check A8, is sum of these 9. Instead of 9, we can write negative 1 to be easier to work with. Negative 1 plus 6 times this. Negative 1 plus 12 is 11 is 1, and you consider negative of that, negative 1. The next one, A12. You say this one plus 6 times this, negative 1 plus 6 times this, negative 6, negative 7. You consider it's 7. A13. You say 7 plus 6 times this minus 6. It will be 1. Negative of that will be negative 1. Sorry. A13 is not. A16 because multiples of 4. A20. Negative 1, 7. Negative 1 plus 6 times 7, 42. 42 minus 1, 41. So it will be 1 mod 10 and it will be negative 1. So because negative 1 was 7, the next one again, it will be what? Negative 1. Sorry, it will be 7. Because negative 1, negative 1, 7. So the repetition we can see from here. We should calculate positive integers, so we should calculate like this. Here, here, here. So up to A1000. Okay. A1000, the problem says to consider. We should consider multiples of 4. So look, 1000 over 4 minus GIF or floor that are multiples of 4. Which of them is bad? Multiples of 12. So minus 1000 divided by 12, floor of them. The first one is 250, the next one is 250 over 3. So it will be 250 minus 250 over 3, which will be 80, 10, 3. And 10 minus 3 is 7, 14 minus 8 is 6, 1 minus 3. So the answer is 167. So there are these AIs, the one's digit will be 9, negative 1 is 9. The one's digit is 9, and they are integer, okay? If you had question, we've worked on a small example, we've analyzed these things. I wanted to show you how to approach a problem. Look, if you solve some problems, you don't need to use all these things completely. When you use 2, 3 small example, you understand quickly the answer is what. Okay, if you had question about this problem or other problems, or wanted to learn important things, how to solve hard problems, feel free to send message to my WhatsApp number in the description and comments. Problem 14, a cube-shaped container has vertices. Let me draw the figure. Okay, a cube-shaped container has vertices A, B, C, D, where A, B, and C, D are parallel edge. This one and this one. Edges of the cube and AC, BD are diagonals of faces. Let me show you AC, diagonal of this face, BD, diagonal of this face. Okay. Of the cube as shown, vertex A of the cube is set on horizontal plane. So we consider horizontal plane such that, let me explain in the rest of the problem I will tell you. So that the plane of the rectangle ABCD is perpendicular to plane P. Vertex P is 2 meters above P. So we consider P, the Z is 0, and okay, so without loss of generality, we can consider the distance to be equal to their Z. So for P it is 2, and so let's write, for example, YB, XB, and then for vertex C is 8, so it will be XC, YC 8. Vertex C is 10 meters above P, so it will be XD, YD 10. The cube contains water whose surface is parallel to P, okay? at a height of 7 meters above P. Okay, because we don't know z coordinate of other vertices, let's calculate them, then we show the water. The volume of water is m over n cubed meters, where m and n are relatively prime positive integers. Find m plus n. Okay, so first, without loss of generality, we can consider A's origin, 0, 0, 0. And without loss of generality, we can consider YB is 0. Okay? We rotate the coordinates such that it is 0, and then the plane P is, we can say, such that their height to the water, or plane P, is their Z coordinates. Because it is 3D, I explain, and I want to solve only with coordinate geometry. If you had question in any part, feel free to send message to my WhatsApp number in the description and comments. Okay, I want to first find all coordinates. Okay, we want to analyze. We have a 3D shape. I want to find coordinates of A. We have A, B, C, D, E, F, G, H. Okay, so let's try. So first, let's focus on AB, AC. AB is perpendicular to AC. And we know dot product, AB dot. You should know cross product, dot product. Okay, we need these two things in the problem. If you don't know them, dot product. I try to explain for only this problem. If you don't know this, feel free to send message to my WhatsApp number in the description and comments. Dot product, it has two things. You can say it is equal to length AB times length AC times cos the angle between them, for example, theta. Because the perpendicular cos 90 between them. Cos 90 is 0. So one way is this. Another way, when they say AB dot AC, AB will be what? XP 0, 2. Dot. AC is what? XC YC 8. Because A is 0. So it will be this 0. Dot product between two vectors. You should multiply x coordinates xp, xc. It's the definition. Plus product of y coordinates 0 times yc plus coordinates product of z coordinates 2 times 8 equal to 0. So we conclude xp, xc plus 16 equal to 0. It's the first thing we know. Now the other thing, the problem, let's see. Because the problem says cube, so for example, if this length is a small a, it's small a, AC is a root a. Okay? Or we can say AC squared is what? If you write, let me explain for you. For this triangle, let me draw like this, or this one, this one, this one. AC squared is C squared plus A squared is A squared plus A squared. Okay? So because we know it is also AC squared equal to A squared plus A squared 2A squared. Okay? And 2A squared, we know A squared is AB squared. Okay? AC squared is what? AC is a vector. Is XC YC 8 squared equal to 2AB squared equal to XB 0 to this length squared. Now we can conclude xc squared plus yc squared plus 8 squared, which is 64, equal to 2 times xb squared plus 4. Now, okay, so first thing we have this. Second thing we have this. Our variables are what? xb, xc, yc. We need one more equation. If we consider AB cross product AC, look, AB cross product AC is a vector, and let me tell you, the vector is cross product. The vector is perpendicular to the plane AB and AC. Let me show you. The rule is this: if you, for example, cross product A times cross product B, so you should you open your hand, your start from A, close your hand to B, then your thumb shows the direction of A cross product B. Now we know that ABAC, their cross product, it is perpendicular to the plane ABCD. And so, okay, so look, we know it is perpendicular to what? To the plane ABCD, okay? And if we consider dot Z, okay? We know Z is perpendicular to plane P, and we know these two things are perpendicular to each other, ABCD and P. So because ABCD, from the assumption of the problem, ABCD is perpendicular to plane P, and this vector Z is perpendicular to P. AB cross product AC is perpendicular. It is a vector perpendicular to ABCD. So Z and this vector, this cross product, they are perpendicular to each other. So their cross product, because it is cos 90, the definition in the beginning of the problem I said, it is equal to 0. Okay. Now, let me show you how you should calculate cross product. Okay. AB cross product AC. You write AB first. It is XB 0, 2. Cross product AC is XC YC 8. So, it is equal to first coordinate, x coordinate. You say this times this minus this times this. 0 times 8, 0 minus 2YC. Okay. For next one, this, you say, okay, 2 times xc minus 8 times xp. So 2xc is the definition of cross product. 2xc minus 8xp. And the last one, if you had question about cross product, dot product, any of these things, as I said before, feel free to send message to my WhatsApp number in the description comments. So this x for z coordinate, xp times yc minus 0 times this. So it will be xp yc. Okay. Now we consider this dot z. So it will be minus 2yc, 2xc minus 8xp, ybyc. Okay? And why here xbyc, sorry. xbyc times z is what? Vector z. 0, 0, 1. So x coordinate times x coordinate 0 plus y coordinate times y coordinate 0 plus ybyc times. So ybyc, the cross product equal to 0 from here. So sorry, xbyc. Here it is x. Let me correct this part. It is xbyc. So let's write all these three equations. The first one, xbxc plus 16 equal to 0. The second one, xc squared plus yc squared plus 64 equal to 2xb squared plus 4. The third equation is xbyc equal to 0. Okay. So because case xbyc equals 0, we consider two cases. Case 1, xb 0, case 2, yc 0. Okay. 0, let's move it here. Okay, let's analyze. If xb is 0 from first equation, we conclude 16 is 0, so that's the contribution. So we conclude yc 0. If you replace yc with 0 in 1 and 2, first one doesn't change, plus 16 equals 0. Second one, xc squared, yc will be 0, plus 64 equal to 2xb squared plus 4. Okay, now we use replacement, or yes, replacement is good. We can say xc is negative 16 over xb. Because xb is not 0 in case 1, we've understood. So it will be negative 16 xb. We replace xc with negative 16 over xb in second equation, plus 64 equal to 2 times xb squared plus 8. Now, negative 16 squared is 256 over xb squared plus 64 equal to 2xb squared plus 8. Now we multiply both sides by xb squared. It will be 256 plus 64. xb squared will equal to 2xb to the 4 plus 8xb squared. Now if you take all things to the right hand side, 2xp to the 4, 8 minus 64, it will be minus 56 xp squared minus 256. Okay. Now we divide both sides by 2, so 0 equal to xp to the 4 minus 28 xp squared minus 128. Okay. Now we try to factorize xp squared. If we consider minus 32 plus 4. The product is negative 128, their sum is negative 28. So xp squared, this part cannot be 0 because it is at least 4. xp squared is at least 0. So we conclude xp squared is minus 32 is 0. So xp squared is 32. So xp is plus minus 32 or plus minus 4 root 2. Okay, here we can say without loss of generality, we can consider the coordinate direction such that xp be positive. Okay, and so like this. Okay, so we can consider xp equal to 4 root 2. Okay, now because xp is 4 root 2, we can calculate xc. So it will be 4 root 2, or let's write xc equal to negative 16 over 4 root 2, it will be negative 4 over root 2, it will be negative 2 root 2. Okay, now we can replace. We can replace in this figure xp equal to 4 root 2. So let's erase this part. xc, yc. yc is 0, xc is negative 2 root 2. xc is negative 2 root 2, 0, and 8. Now we can also find length is what a. Because a equal to ab equal to square root of 4 root 2 squared plus 0 squared plus 2 squared. 4 root 2 squared is 16 times 2, 32, plus 2 squared is 4, 36, so it is 6. So length is 6, okay? So we can erase these a's and write 6 instead. Okay. Now, okay, we found A, we found B, we found coordinates of C. Now we want to find coordinates of E and F. So we consider, for example, A. For E, we consider X, E, Y, E, Z, E. For F, we want to say it is XF, YF, ZF. And then you can say by right hand rule, AB times AF, AB cross product. Right hand rule was this. AB times AF cross product AF, if we use it will be equal to AE. Now, because it is perpendicular to this, if we consider AF AE, AF cross product AE equal to, if you close your hand from F to E, your thumb will be in this direction. It will be AB. AB, AF, AF, AE, AB, AE. AB, AE, you should close your hand from E to right hand, from E to B. AE cross product AB equal to AF. Okay. So let's consider each of them. The first one, so we can see three things. Because A is origin, you can write first one AB as 4 root 2, 0, 2. Cross product AF, XF, YF, ZF. Okay, now here, for x coordinate, you say 0 times ZF minus 2YF, so minus 2YF. For y coordinate, it will be 2XF minus 4 root 2 ZF. For z coordinate, you say 4 root 2 YF minus 0 times something. Okay. And we know it is equal to AE, which is XE, YE, ZE. We have 6 variables that we want to find. So here you can use, for example, 3 equations. And the variables here we have. So let's consider now AFA. AF is what is XF, YF, Z. XE is what AE is what XE, YE, Z. And if you calculate, it will be YFZE minus ZFYE by the definition of cross product. YF this, you say next one, ZFXE minus XFZE. And the last one, XFYE minus YFX. Okay. So here we know it is equal to AB, which will be 4 root 2, 0, 2. The last part that is left, AE will be XE, YE, ZE cross product AB, which is 4 root 2, 0, 2. If you calculate this for first one, 2YE, for second one, 4 root 2 ZE minus 2XE, and for third one, 0 minus 4 root 2YE. Equal to AF, XF, YF, Z. Okay, so we have these 3 equations. We want to find these things. Also, look here. We know if we add, because we have C, we know AE plus AF equal to C. So we can say X, because AE plus AF equal to AC. So AE is XE, YE, ZE plus this will be XE left hand side plus XF, YE plus YF, ZE plus ZF equal to AC. AC is what? Negative 2 root 2, 0, 8. 2 root 2, 0, and 8. Okay, let's write the things we have. XE plus XF equal to negative 2 root 2. YE plus YF equal to 0. ZE plus ZF equal to 8. And we want to use replacement to solve this. Then, if you consider these equations, let's copy the first one. And we can write new equations. We can say negative 2YF equal to XE, 2XF minus 4 root 2 ZF equal to YE, 4 root 2 YF equal to ZE from the first part. Now let's erase this and consider second part. This part. Okay, let's copy this part and write the rest of the equations. YFZE minus ZFYE equal to 4 root 2. ZFXE minus XFZE equal to 0. XFYE minus YFXE equal to 2. Let's erase this part. And the last 3 equations equal to what here we have. 2YE equal to XF, 4 root 2 ZE minus 2XE equal to YF minus 4 root 2 YE equal to ZF. Okay. So we have 1, 2, 3, 4, 12 equations. From first 3 equations, I want to get rid of all things about F and write all of them in terms of E. So xf equal to negative 2 root 2 minus xe. Yf equal to negative ye. And zf equal to 8 minus ze. Now, for example, let's consider this equation negative 2yf. So it will be negative 2 negative ye. Look, I've combined this and this on left hand side equal to xe. Okay, so we conclude xe equal to 2ye. Now, let's consider this one here and this one. So 2ye equal to xf. Xf is what? Negative 2 root 2 minus x. So 2xe equal to negative 2 root 2. So x equal to negative root 2. And now, because we know xf equal to what? Negative 2 root 2 minus xe minus root 2. So negative 2 root 2 plus root 2, it will be negative root 2. So xf is this, xe is this. Now let's focus on ye. Ye is xe over 2. Okay, so ye is xe over 2. So it will be negative root 2 over 2. Oh, sorry, one thing that I forgot here when we consider cross product, you should say this times this. The direction is this. But because there are 90, the length will be length of AB times AF, which is 36. But because right side length is 6, so we should multiply it by 6. Okay? So the only thing we should do, multiply all of them, the right side by 6. Okay? And the last part, 6. This one is okay. So here we should write 666 here. Here we should write 24, 12, 0. The last part 666. Okay. And here the only thing we should do here, we should place 6. 6. Let me write them. Or it's okay. 6, 6, 6 here. So let's write. It will be 6 xe, 6 ye, 6 ze. Here it will be 6xf, 6yf, 6zf. Here 24 multiple 12. Okay. Now that we know these things, okay, let's calculate again. Okay, let's use this one and this one. Okay, so we know, or let's do something. This one and let me show you this one and this one. Okay, so negative 2 yf is negative ye equal to 6xe. Okay, so if we divide by 2, ye equal to 3x. Okay, now we use this 2ye equal to xf. 2ye equal to 6xf. Instead of xf, we replace it with this. Negative 2 root 2 minus xe. Okay, so if we divide both sides by 2, we conclude ye equal to negative 6 root 2 minus 3x. If we combine these two things, so 3xe, because ye equal to ye, 3x equal to negative 6 root 2 minus 3xe. If we take 3xe to left hand side, 6xe equal to negative 6 root 2. So xe equal to negative root 2 is the first important thing. And now we want to calculate xf. Xf equal to negative 2 root 2 minus xe minus root 2. It will be minus 2 root 2 plus root 2. It will be negative root 2. So it is what? It is xf. Now let's calculate ye. Ye is 3xe. So ye is negative 3 root 2. Now yf is negative of that. Yf is negative ye, which will be 3 root 2. The last part that is left, zf, ze. So here, let's see, can we find any relationship? From this part, zf equal to negative 4 root 2 over 6 ye. It will be negative 2 root 2 over 3 ye. y is what? Negative 3 root 2. And if we cancel 3, 3, negative, negative, positive, 2 root 2 root 2 is 4. Okay, and ZE is what? ZE is 8 minus ZF. 8 minus ZF, which is 8 minus 4, which is 4. Okay, so let's write now the coordinates. E will be what? XE negative root 2, YE negative 3 root 2, ZE is 4, and F is what? XF. XF is negative root 2, YF is 3 root 2, ZF is 4. Okay, so let's write on the cube. Okay, so I've placed E and F are what? Now, the rest of coordinates, the rest of vertices, finding their coordinates is so much easy. For G, we know that AF plus AB equal to AG. Okay, so so AG is equal to AF is negative root 2, 3 root 2, 4 plus AB is what? 4 root 2, 0, 2. Okay, 4 root 2 minus root 2 is 3 root 2. And the next one, 3 root 2 plus 0 is 3 root 2. 4 plus 2 is 6. Okay, so we found G is what? 3 root 2, 3 root 2, and 6. Now let's calculate. We know C is what? H. AH equal to AB plus AE. So AB is 4 root 2, 0, 2, plus AE is negative root 2, negative 3 root 2, 4. So it will be 3 root 2, negative 3 root 2, 4 plus 2, 6. Okay, so let's write also H is what? 3 root 2, negative 3 root 2, and 6. And the last part is D. For D, you can say AF, AD equal to AF plus FC plus FG. AF is obvious, negative root 2, 3 root 2, and 4. FC is C minus F, so it will be negative 2 root 2, negative root 2, negative 3 root 2, and 4. Plus FG is 3 root 2, 4 root 2, 0, 6 minus 4, 2. Okay. Now, if we add negative root 2, it will be 2 root 2, 3 root 2, negative 3 root 2, 0, 4 plus 4 plus 2, 10. Okay, so 2 root 2, 0, 10. Now, by these things, we can conclude the water is, it's 7. Let me show you it will be up to what part. Okay, now we want to calculate the water. It says all Ln, for example, suppose between this red plane is water. Now we can say that we should calculate this volume, or you can calculate whole volume 6 cubed minus this volume. Okay, now for calculating this volume, we can continue this. Let me show you, and you can continue this, and you can continue this part. Okay, so it will be something like, if I want to erase the rest, and you can prove the plane will be same, so it will be something like this from here. And let me draw this part, this part. We can say it is, for example, K. The bad part is this bad volume. So you can say area of the volume of the answer is 6 cubed minus volume of DC, for example, DC ln m PM. And you can say is equal to 6 cubed minus volume of dmpk minus volume of cnlk. And it's good because for each of them, because for example, first one, is connected to mpk, you can say the height times area. Okay, and for the next one, cnlk, you can say this height times area. Now, how can we find the height? Because mp, all these things, their z is 7. The problem says the height of water is 7. So we can say the first one is 6 cubed minus. We have first one, this is 10. 10 minus 7 is 3. And at first you should say 1 over 3 because it is a point connected to all other points. 1 over 3 times the height, which is 3, times area. Area of what? kmp. Minus area of this. C is 8, so the height is 1, so 1 over 3 times 1 times area of knl. So if we can find the area of kmp and area of knl, the problem will be solved. Okay, for finding area of kmp, we should know the coordinates of kmp and also knl. We should find the coordinates of knl. Let me tell you how to find. It has a formula that, for example, let's consider z coordinates. We know z coordinates of p is 7 because the height of water from P is plane P is 7. So 10 minus 7, you can say 7 minus 6, 1. 10 minus 7, 3. So we can consider, for example, it is 3t, it is 1t. Okay, because the difference 10 minus 7, 3, 7 minus 6, 1. It is the way when you want to find the coordinate of a point here. For example, if P was midpoint, you set this coordinate plus this coordinate over 2. Now, because it is 3t, you multiply this coordinate by 3, you multiply this coordinate by 1, and then divide it by 4. So let me tell you, P will be what? 3 times 3 root 2, 9 root 2, plus 2 root 2, 11 root 2 over 4. It's x coordinate, y coordinate. 3 times 3 root 2, 9 root 2, plus 0, 9 root 2 over 4. And the last one, 3 times 6, 18, plus 1 times 10, 28 over 4. It will be 7. Now let's erase this part. We found P like this for M. 10 minus 7, it is 3t again. 7 minus 6 is 1t again. If you want to find M, let's calculate. 3 times 3, 9 root 2, plus 1 times 2 root 2, 11 root 2 over 4. Why you say over 4? Because the sum. So we divide by 4 because the sum of coordinates equal to 4. Let me erase this t. Okay. Y coordinate is 3 times this minus 9 root 2 plus 0 over 4 minus 9 root 2 over 4. And Z coordinate is 3 times 6, 18 plus 1 times 10 is 28 over 4 is 7. Now let's calculate L and N like this. So here it is 7, it is 8. 8 minus 7 is 1. 7 minus 4 is 3. Again, here we should consider 3t. Now, let's calculate L. 3 times this, negative 6 root 2 times this, negative 7 root 2 over 4. 3 times 0, 0, plus 1 times this, negative 3 root 2 over 4. 3 times 8, 24, plus 1 times 4, 28 over 4, 7. Okay, we found L. 2 points are left. We want to find N. N will be what? 8 minus 7, 1t, 7 minus 4, 3, 3t. So 3 times this negative 6 root 2 minus this negative 7 root 2 over 4. 3 times 0, 0. 1 times this 3 root 2 over 4. 3 times 8, 24, plus 4, 28 over 4, 7. Now, the last part is k. So let me erase this part. k 7 z coordinate to this t to this one 10 minus 7 3. When you want to calculate when k is outside, let me write k here. The formula is this: 3 times this minus 1 times this over 2, because the difference of coefficients important. So 3 times this negative 6 root 2 minus 1 times this 2 root 2 negative 8 root 2 over 2 negative 4 root 2. And y coordinate, because it's 0, it will be 0. Z coordinate, we know 7, but if you check 3 times 8, 24. Minus 1 times 10, 24 minus 10, 14 over 2, 7 again. Okay, so we found all these things. Now the only thing we need to calculate is to find area of KMP, area of KNL. So let me tell you, if you want to find area of KMP, it has a formula with cross product. You can say equal to 1/2 times Km cross product Kp. Okay, so it will be 1/2. Km is what? K minus m. So it will be m minus k. 11 root 2 over 4 minus 4 root 2. And negative 9 root 2 over 4 minus 0. 7 minus 7 0. Times cross product Kp. Let's consider Kp. Negative 4 root 2 on, because p minus k, it will be 11 root 2 over 4 minus 4 root 2, 9 root 2 over 4 minus 0, 7 minus 7. Now let's calculate. Let's simplify. It will be 1/2 times. It will be plus 4. 4 times 4, 16. 16 plus 11, 27. Root 2 over 4, the first coordinate. And the next coordinate, negative 9 root 2 over 4. And 7 minus 7, 0. Cross product. 16 plus 11, again 27 root 2 over 4. 9 root 2 over 4. And 0. Okay. So if you calculate this cross product, you say 27 root 2 over 4. Negative 9 root 2 over 4. 0. Cross product 27 root 2 over 4. 9 root 2 over 4. And 0. Okay. So now it will be what? For x coordinate, this minus this, which will be 0. For y coordinate, this minus this, 0. For z coordinate, this times this minus this times this. So let's consider 27 root 2 over 4 times 9 root 2 over 4 minus this times this. Negative 9 root 2 over 4 times 27 root 2 over 4. It is the formula of cross product. Okay, you need that when you have 3D, you want to find area of a triangle. So let's calculate. It will be 1/2, 0, 0. 27 times 9 is 63. 243 times 2 over 4 times 4. We can cancel this. It will be 2. The denominator will be 6. Minus minus plus 9 times this. Again, 243 times 2 over 4 times 4. It will be 2. So here, because it has only one coordinate, we should consider the length is this. 24 over, let me calculate, 24, 243 over 8 plus 243 over 8. So it will be 1 over 2 times 243 over 8. We cancel these things, so the area of this part is 243 over 8. Now let's calculate the next area, K and L. So area of K and L equal to 1/2 times Kn cross product KL. Okay, let's calculate this area. It will be 1/2 times kn. It will be n minus k. And it will be negative 7 root 2 over 4 minus 4 root 2. And okay, it is n minus k. Yes, it's okay. The next one, 3 root 2 over 4 minus 0, 3 root 2 over 4. 7 minus 7, 0. Cross product KL. Negative 7 root 2 over 4 minus 4 root 2. KL, this minus this, negative 3 root 2 over 4. The last coordinate, z coordinate, is 7 minus 7, 0. And now let's simplify. It will be 1/2 times 4, 16 minus 7 is 9. 9 root 2 over 4. 3 root 2 over 4. And 0. Cross product. 4, 16 minus 7. 9 root 2 over 4. Negative 3 root 2 over 4. 0. Okay. And if we calculate this for, let's consider x coordinate 0, 0. Y coordinate 0, 0. And z coordinate, it will be this times this minus this times this. This times this will be negative 27 root 2 times root 2 is times 2 over 4 times 4, 16. Minus this part, 27 again, times 2 over 16. And if you calculate, this will be 8. This will be 8. So it will be 1/2, 0, 0. Because we have twice of this, it will be negative 27 over 4. So it will be 1/2. The length here is 27 over 4. So it will be 27 over 8. Now let's replace 27 over 8 for K and L. 27 over 8. And for area of KMP, it was 243 over 8. 243 over 8. So let's simplify. Because here we have 27 divided by 3 will be 9. Here divided by 3. Because we have 3 here, we can cancel these 2 3. So it will be 600. 6 cubed is 216. Minus 243 over 8. Minus plus 9 over 8. And if you use common denominator, let's calculate this first. Plus common denominator 8 minus 243 plus 9. It will be 216. Minus 243 minus 9 is 234 over 8. If we divide by 2, it will be 117 divided by 2 is 4. Now, if we use common denominator 4, it will be 4 times 6, 24. We have 2. 4 times 1, 4. Plus 2, 6. 4 times 2, 8. Minus 117. Okay, if we calculate this, it will be 14 minus 7, 7. 5 minus 1, 4. And 8 minus 1, 7 over 4. The problem says what? The problem says when you find the area, let's calculate. This m over n, m plus n is what when m and n are relatively prime. Here m and n are relatively prime, so the answer is m plus n, which will be 747 plus 4, which will be 751, and the answer is this. If you want to learn more things like, for example, cross product in 3D, for example, the things you should know, the basic things, distance of a point from a plane, a lot of things. How to work with lines, how to work with planes in 3Ds, also in 2Ds. The important formulas, basic formulas, if you want to learn them, as I said before, feel free to send message to my WhatsApp number in the description and comments. Problem number 15, AIME II 2023. It says for each positive integer n, let a n be the least positive integer multiple of 23 such that an is congruent to 1 mod 2 to the n. Find the number of positive integers n less than or equal to 1000 that satisfy an equal to an plus 1. Okay. So let's check. Let's try to find a1. we know A1 is multiple of 23, so we can say A1 is 23B1. Considering a small example is good. We can little understand problem wants exactly what. So 23B1 is congruent to 1 mod 2 to the 1 or mod 2. So we can conclude that 23 mod 2 is 1, so B1 is 1 mod 2. Because it wants the minimum AN that is positive, so B1 should be minimum, so B1 will be 1. And A1 here will be 23. Okay, so in next step, for example, let's find A2. A2 is 23B2. 23B2 mod 4 should be 1 because 2 squared is 4. 23 mod 4 is negative 1. So negative B2 is 1 mod 4. And we can say B2 is negative 1 or plus 4, 3 mod 4. So B2 we know is positive. The minimum B2 is 3. So A2 in this case equal to 3 times 23, 69, and A1 is 23. Let's check next one. A3 is 23B3. Now 23B3 also is 1 mod 8. Again, we can use same thing. 23 mod 8 is negative 1. Negative B3 is 1 mod 8. So B3 is congruent to negative 1 or 7 mod 8. Okay, so B3, the minimum B3 is 7. So A3 will be 7 times 23. 7 times 3, 21. We have 2. 7 times 2, 14 plus 2, 16. Okay, so we've not found anything that are equal. Let's check A4, for example. It's 23B4. 23B4 is congruent to 1 mod 16. 23 mod 16 is 7. 7B4 is 1 mod 16. And we can multiply it by 3, then 5. Or we can also multiply it by 7. So 49B4, 49 is 1 mod 16. So B4 is 7 mod 16. Then we conclude, okay, minimum B4 is 7. Okay, so it's the first time we see two AIs are equal, consecutive AIs, A4 equal. So we found this, we can calculate A4, B4, we've calculated up to A4, B4, we can calculate A5, B5, and so on to understand. Let's now focus, it's good, up to here it's okay, we've understood many things. Let's work on variables. Look, for example, we know AN equal to 23BN, so 23BN is 1 mod 2 to the n. So we can say that 23BN equal to 2 to the n Cn plus 1. And we can also consider it mod 23. We know 2 to the n Cn is congruent to negative 1 mod 23. Why? Because mod 23 left side is 0, right side is 0, so 2 to the n Cn is congruent to negative 1. Now here we should find, for example, minimum Cn. Satisfy this if possible. So let's consider. So if we determine Cn minimum, look, because we want to find minimum AI, it is equivalent to find minimum BI. For finding minimum BI, it is equivalent to finding minimum CI. This, okay, so here if you find CI that is multiple of 3, can satisfy this equation, it is congruence, it is modular, then the minimum CI that satisfies this minimum BI, minimum AI. But how can we find the minimum Cn that satisfies this? Okay, because we say 2 to the n, we should find the repetition, for example, 2 to the n mod 23, what happens to this? So look, if we consider 2 to the 1 is 2, 2 to the 2 is 4, 2 to 3 is 8, 2 to the 4 is 16, 2 to the 5 is 32, 32 mod 23 is 9. Then 2 times 9 is 18. 2 times 18 is 36. 36 is 7 times 6 13. 2 times 13 26 is 3. 2 times 3 is 6. 2 times 6 is 12. 2 times 12 is 24, which is 1, then 2. And we will see this repetition, okay? You can also say this with some professional things like order and considering that, but also this repetition is okay. 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's calculate 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so the repetition is 11. So it is important that n, the remainder of n when divided by 11 is what? So we can say n equal to 11, for example, dn plus rn. Okay, now rn is important because 2 to the 11 is 1. So 2 to the n Cn is 2 to the 11 dn plus Rn, which Rn is at least 0 less than or equal 10 times Cn equal to 2 to the 11 dn times 2 to the Rn. Cn, the first one is 1, is congruent to 2 to the Rn times Cn is congruent to negative 1 mod 23. So let's Ci is only related to Rn. Now, let's consider for each Rn we want to see Cn is what? But we can do something. We can say, okay, if we multiply both sides by 12 to the Rn, we can say the left side will be 24 to the Rn Cn, right side will be negative 12 to the Rn mod 23. Because 24 is 1, then we can conclude Cn is congruent to negative 12 to the Rn mod 23. Then we can calculate for each Rn. Cn is what? Now we should draw a table for Rn Cn. Okay? Now, here Rn, Cn, Rn can be 0, can be 1, can be 2, can be 3, can be 4, it can be 5, can be 6, can be 7, can be 8, can be 9, can be 10, can be 11. And Cn is 1. So for C0, it will be negative 12 to the power of 0, it's negative 1. Negative 1 because Cn should be positive, we can say it's 22. Now, let's consider next one, or C1. C1 here is negative 12 to the power of 1, negative 12. 23 minus 12 is 8 plus 3, 11. For next one, 2. C2 is negative 12 times 12 mod 23. You can say it is equal to negative 2 times 12, 24 times 6. And instead of 24, you can write 1. It will be negative 6. It will be 70. So 2 is 70. Now next, C3 is congruent to negative 12 times 12 times 12. So you say, okay, you write 2 times 12, 24 times 2 times this 24 times 3. 24 is 1, so it will be negative 3, it will be 20. For 3, it is 20. Now, we can pause the video and try to calculate C4, C5, C6 to C11, C10, sorry, because we've considered C0. C4 is negative 12 to the power of 4. You can do something. You can say, okay, we've calculated previous one, but you only multiply it by 12. So 20 times 12. It will be what? It will be 2 times 12, 24, 10 times 24. 24 is 1, so 4 is 10. Next one. 10 times 12. Again, you say, okay, 2 times 24, 12, 24. 5 times 24, it will be 5. The next one. 5 times 12. So it will be 60 mod 24, 48, 12. For 6, it will be 12. I'm sorry, 60 mod 23, 46, 14. Let's correct this. 14 4 numbers are left. The next one, 14 times 12, you say, okay, it's 7 times 24. 24 is 1, so it's 7. Next one, 7 times 20, 7 times 12, which will be 84. 84 minus 23 times 3, which will be 69. So 170, 15. For 8, it will be 15. And the next one is 15 times 12. So we can say it is 14 times 12 plus 1 times 12. It is 7 times 24 is 7 plus 12 is 19. And the last one, 19 times 12, you say 18 times 12 plus 12. So again, you can say 2 times 12, 24, 9 plus 12, 21. Okay, so we've calculated all CIs. Now, why it's important? If an equal to an plus 1, let's see what happens. Suppose an equal to an plus 1. So we conclude that 23bn was what? Was an. So we conclude 2 to the ncn plus 1, 2 to the ncn plus 1 equal to 2 to the n plus 1, cn plus 1 plus 1. Now, if we cancel 1, and if we divide both sides by 2 to the n, so we conclude cn equal to 2cn plus 1. So we should see, it is like a cycle. Look, C0 is twice C1, it's good. 11, 17, 20, 20 is twice 10, 10 is twice 5, 14 is twice 7, and okay. For each 11 cases, we will see these things. So let's see here the thing we found they are equal, A3, A4. So look for 3, 4, yes. Look for 3, 4, we find that they are equal. So let's see. If we consider from A1, the first thing they are equal is A3 equal to A4. The next one, A4 equal to A5. The next one, A6 equal to A7. And the next one, A11 is like 11. A11 equal to A12. Okay, we have these things. 3 to the next one, 4 next one, 6 next one, 7 next one. So 3, 4, 6, 11. The next one are equal. Now, it says calculate from 1 to n less than what? N less than or equal to 1000. Okay, an equal to an plus 1. So we should check a1, are they equal to, or a1000 equal to a1001. So in the next part, when we add by 11, it will be 14, 15, 17, 21, and 22. Okay, if we continue, 11 plus is 22. You will see 999 and all these things. For example, this one, you can say minus 5, 994, 992, and 991. I'm sorry, here 990 is multiple of 11. So let's consider 990 minus 5, 985, minus 2, 983, minus 1, 982. Okay, it is this. Now, in next case, you add by 11, it will be 993. Then you add 994, then 996, then 5 will be 1001. We will see 1001 is not good because 1001 with 1002 are equal. So we cancel these. Now we should calculate all these things. If we want to find the number of cases, we say, okay, let's consider 1001 over 11. Look, 22 over 11, the number of groups. For example, it is one second group. If we divide it, it will be 9, 99, 11, 91. So it will be the 91st one, 90. So we have 91 groups, 91 times 4 minus 1. And if we calculate that, it will be 4, 6, 3 minus 1, 363. Okay, AMC, I don't remember, 12B or 12A. The last problem was similar to this, and in that case, you should prove by induction, and you could also solve with considering a small example. So if you want to learn how to approach problems, look, I didn't want to tell you only the solution, the last answer. I just wanted to show you how you can solve a problem with basic things, with considering small examples. Also, here, if we want to prove it, we can use induction, how we can apply these basic things for harder problems. And then, for example, for SUMEC, promise, there are summer camps applying, and if you can pass their, for example, application test, it will be so much good for your CV. Also, for applying universities, if you want to participate in IMO, harder math exams, AMC, AIME, USAMO, BMO1, BMO2, all around. You can participate in these two exams from UK. It's one of them for UK BMO, and AMC, AIME, USAMO for USA. You can participate in both exams from all around the world, and it will be so much good for your CV. If you want to learn the ideas, 40, 50 important formulas in geometry, number theory, combinatorics, algebra, if you want to learn them, as I said before, 40, 50 important formulas you should memorize. If you want to learn them, as I said before, feel free to send a message to my WhatsApp number in the description and comments. Okay, thanks. Bye.